Hello, everyone. How are we doing? Oh, is it a triple header? Is Ranks doing his word thing right after this? I was uh, I was thinking today if I wanted to do the sudoku, but I think I want to watch Ranks do the sudoku or whatever it's called. There's too many syllables for me to remember. The 16 one. The 16 one is the one I like the best. Um, how is everyone today? Is my sound okay? Is it coming out of the right place? All of these things. The music is now labeled at the top right. So we have a cycle of music, and it does get labeled. Uh, hey, Turvold, Casey, Eleventicles, Nemusic, David, Sarvesh, Ranksk. Let's see, Directionary I saw was here, Barbie I saw was here, Jessica was here, and got lots of people here. It's really nice starting right after Ranksk has gotten everyone all excited up. Glad you're enjoying the music, Pankuri. Yeah, that was it has all been a Tristan effort to have there be a little bit of a bit of music, and it turns out there's a good chunk of royalty-free music out there, so that we could do it, and now it's properly credited and everything. So pretty happy about all of that overall, uh, and also happy about the number of five-list puzzles that we have seen. So we're doing well at removing the number of five. So currently, I believe there are 20 submitted five-list puzzles. So Wednesday's stream is set up to be five-list puzzles. And probably it will be stream one of more than one five-list puzzles, would be my guess. If I were to currently predict, I think probably I'll start five-list puzzles net on Wednesday for five-list day. And then I will continue doing five-list puzzles on Saturday. And then I think the Wednesday following, I'm going to do Clover's storybook, I think is the plan. So that's my rough plan. So you've still got plenty of time to get in your five-list puzzles if you would like to have a five-list puzzle done by me on stream. Five-list Sudoku puzzle, I should say. Alrighty. Well, welcome to all of you. Thank you all for coming. Thank you all of you who are subscribed. If you're not subscribed yet, please consider subscribing. It does help. I'm very excited to get to 1,000 subscribers. We're not quite there yet, but we're making good progress. So that's my goal at the moment. It unlocks a lot of YouTube's features are sort of locked behind a wall that you can't get to until you're at 1,000 subscribers and a certain number of hours of watch time. But the number of hours of watch time, we're like way past that, because you all watch me a great amount, which I greatly appreciate. But the number of subscribers, we're just a little short of that, so I'm hoping that we can get there. Ranks just got there. I'm very excited. I don't know if Ranks has announced yet exactly what he's doing with the puzzles he got to celebrate getting to 1,000 subscribers, but I did submit a puzzle to Ranks to celebrate him getting 1,000 subscribers. It's on Logic Masters Germany. It's called Frack, and it is a very cool region sum lines puzzle, in my opinion. Also, if you like to play along with puzzles that I've released, I just released in the Discord Puzzle Archive a puzzle called Modern Romance that is sort of a variant on XV Sudoku, sort of. It includes in the rules the sentence, all hearts are given. So I encourage you to look at that if you want. It'll probably be on LMD now that it seems like Logic Masters Germany is real again. Logic Masters Germany was not letting people post comments or rate things for some long amount of time there. It seems like it's fixed, because I got some emails saying that people made comments. So maybe I will get Modern Romance up there. All there at that. But I think Naverio has said that on Monday he's going to be streaming a chunk of puzzles by me. So if you want to plug your stream in chat, Naverio, by all means. If somehow you can't post a link, Tristan can help you with that, although I think you can just post a link directly. Yeah, I did submit Modern Romance to Rank's stream as well, so it should eventually show up there. If you want to PM me or ask in chat, you can do so. I can do that. Alrighty. So I looked. I was talking to Tallcat, and I realized that I had not done a Tallcat puzzle in a while. and I looked and was like, oh yeah, I've got all these tallcat puzzles in here. Back when the stream was much smaller, it would be like, oh, tallcat's always here, so I'll do a tallcat puzzle or two every stream. But now I've done them in a while, and the first one I found was like a pure vanilla arrow, but then I found this one. So we're doing this one. That is the moral of the story. All right, so how does this work? So this is a combination of two rule sets that have shown up a lot in this stream, if you're a regular around here. And those rules are 159 and X sums. So let's do the 159 first. So the pink strips here are just a reminder of the 159 rules, which tell you if you... oops, sorry, that's a color. If you put a number here, which you, by the way, have to, because there's usual Sudoku rules. So I have to put a number here. It could even be a 5 in this puzzle, but not next Wednesday. Then what this number tells you is it tells you the secret location of the digit 1 in the row. And so this 7 is telling you that secretly the 1 is there. Now that it's the 1 because it's in this column. If I put a 7 here instead, it's telling me that actually this digit's a 5. And if I put a 7 here, it's telling me that this digit is a 9. Now, of course, I can't put 7s in all of these because I can only put 1 of 1, 5, or 9 here. I should mention, by the way, Navario's not only streaming my puzzles. Navario's been streaming a lot of Sudoku of late, so please check out his stream, even if it's not just to watch him do puzzles by yours truly. All right, so the other rule is the other rule is that these things here are X sums. And so whatever digit you put here is the X in X sum. So if this is a 7, it's telling you that this is a 7 sum, which means that you would sum these 7 digits, and then you would get 20. Well, that's probably not going to work. But if I were to make this, for example, a 3, we're doing just great with the colors today. If I were to make this a 3 and make these an 8, 9, then that works out. This is a 3 sum, so to speak. Something phrasing. And so this 3 sum here, consisting of the 3, the 8, and the 9, sums to 20. And the rest of the digits just don't matter at all. So always the first digit read from this direction is the thing that tells you how big the sum is that you're looking for. Okay, and that is all that there is to the world of this puzzle, unless there's extra rules. And based on last stream, there's probably 3 extra rules that I did not read because I did not actually read the rules. So chat will tell me if there are extra rules that I missed. But other than that, we can start. And the place I always start on X sums is putting the digits that could possibly go in these cells. That is, the digits that could possibly be the X in every cell. So Tristan points out that this can't actually ever be a 3. Because if this was a 3, you'll notice what I did there does not actually work. Because this is an 8-9 pair, but this cell is also, because of the 159, a 1. And so if this is a 3, in order to make this a 3-cell 20 clue, I would need to make this cell a 16. But that would repeat the 1, so that's not allowed. So this can't be a 3. So this has to be at least a 4. Now, it can't be as high as 6, because 6 digits already sum to 21 at absolute minimum, and probably more, and so that's not going to work either. Okay. Hey, Ambrose, welcome. Now, the 14, so the thing about 14 that stands out immediately is 14 is 1 less than 15. So that means this can't be a 5, because if this were a 5, the maximum I could get, the minimum I could get would be 1, 2, 3, 4, 5. And so 14 is less than that, so that means that this digit has to be a 2, 3, or 4. but it can't be a 2 without putting a 12, which again would repeat the 2, so not allowed. So this is a 3 or a 4. Exactly the same thing applies to this 14 clue over here. Now let's do the 15. So can't do 2, it's too small. Could do 3, 4, or 5, I believe, at least before we think about it more. Probably once we think about it, there'll be a problem that Tristan will explain involving X sum clues as to why this can't be one of these numbers. I'm not quite sure I see it yet, but someone will. Now, 19, again, has to be at most 5, but at least 3. So this is from 3, 4, 5. 22 now needs to be, I can't get there in 3. I could get there in 4, 5, or 6, except there's this weird thing that happens in X sums, I think, where 22 is actually impossible in 6. Because 22 in 6 would mean that I need these 6 digits to sum to 22. Except that 22 digits, 6 digits summing to 22 would have to be exactly the digits 1, 2, 3, 4, 5, and 7. Which has the funny problem that although it's 6 digits, it doesn't have a 6 in it to be the X for the sum. So if you know your triangular numbers, those are the 10, 15, 21, etc. numbers that are the sum of the first n numbers that are important in so many different Sudoku variants for whatever reason. The ones that are special in X sums are the ones that are one more than a triangular number. So in this case, it's 1 more than 21, which is the 6th triangular number, is 22, which is why ultimately this can't be a 6. Okay. Now, someone is pointing out in chat, I think it was Barbie who saw it first, this digit actually can't be 5. Surprisingly, I don't think it was Tristan. But this can't be 5, because if this was 5, then these would be 1, 2, 3, 4. And this is an excellent opportunity to explain why this doesn't work. And the reason why this doesn't work has to do with something that arises out of 159 logic in a way that's not clear. Not clear immediately, I should say. And that is that both of these boxes have a 5 in them. I'm really interested in where the 5 is in this box. And it could be in any of these cells. Not that one. This is not the 5 in that box. But the thing about these boxes is that wherever the 5, these cells, wherever the 5 is, it's going to put a 7, 8, or 9 to index that 5's column in one of these two cells. Now, you'll notice the problem here is that these digits cannot be 7, 8, or 9. And so actually, without it being sort of on the surface clear, if you haven't done these puzzles, we've accidentally made it impossible to put a 9. Sorry, not a 9. We've accidentally made it impossible to put a 5 in box 3. So that's not going to work. In fact, actually, if you look closely, we're going to have to put a second 5 in either box 1 or box 2. Because if you look, actually, these really can't be 4. Because if either of these were 4, it would put a 5 here. And that would be a second 5 for the box, so that's not going to work. And so ultimately that tells us this digit can't be 5. Okay. Now, a way of expressing what we just said that may have seemed confusing in a way that is consistent and useful involves the concept of high, mid, lowity. So in things like German whispers, you divide digits into high and low and whatever you want to call 5, bad. But in 159, you want to actually divide them into 3 categories, the high, the mid, and the low, which are 1, 2, 3, 4, 5, 6, and 7, 8, 9. And the key observation is because of what I was saying about where these pink digits put that digit in the boxes around them, I need A1, 2, 3 amongst these 3 digits. It doesn't have to go at the top, but I need A1, 2, 3 to correspond to the 5 that's going to be in box 4. I need a 4, 5, 6 to correspond to the 5 that's going to be in box 5. And I need a 7, 8, 9 to correspond to the 5 that's going to be over here in box 6. And so there's always going to be a high, mid, low split amongst the 3 pink digits in any box. So that is a universal rule of 159s, and hopefully I have explained why it is true if you have not done that. Yes, it's like entropy. I would hypothesize that entropy lines are a direct consequence of someone doing a lot of 159 puzzles, but I could have the causality backwards. Okay, so now Naverio claims that things are going to go very well when I write down what this can be, I think. This being 24. Now, it can't be a 1 or a 2. If it were a 1, it would have to also be a 24. If it were a 2, it would have to be a 2 and a 22. That's not going to work. It can't be a 3 or 4 just by sudoku. So this is at least 5. And it could be 6, possibly. But it's certainly not 7, because if this were 7, then it would add to at least 28. Okay, now, the problem with this being 5, as Naverio sees right away, is that if this is a 5, then that would put a 7 in this cell. Except, spoiler, I can't put a 7 in this cell. It's 3 or 4. And 7 is the sum of 3 and 4, which is not a thing that I'm allowed to do in this puzzle. So, ergo, this is not a 5, it is a 6. And we get a digit dance before I'm really done explaining the rules. I don't know why the punching got mixed in, but the punching seems to have become a part of the digit dancing. So we live with it. Okay, so that's a 6. So these 5 digits add to 18, for whatever that's worth. And let's see, we've got one more over here. So 4 plus 9, 8, 7 would be the most I could do if this were a 4. So 4 is not big enough. So this has to be at least 5. And then it could go up to 6 or 7. 8 is too many, though. So this is a 5, 6, or 7. And Naverio is pointing out I should have long ago, and I completely agree, pencil mark the fact that this 3-4 pair actually tells me something. Namely, it tells me, because of the 159 logic, that these two cells are a 1-5 pair. Whichever of these is a 3, the 1 or the 5 goes in the third spot, and then the other one's a 4, and the 1 or the 5 goes over here. So actually, this is a 1-5 pair. And we can do similar things like, because this is a 4-5, we can pencil mark that means one of those two cells is a 1. This being a 3-4 means we can pencil mark that one of these cells is a 9. I'm going to go ahead and draw a line across there, just because we pencil marked across boxes, and it will make some people sad if I do that too aggressively. And I'm not in the making people sad phase of the stream yet. What did I do wrong? Or is Barbie just sad I pencil marked across boxes? Because I have a line to indicate that I'm pencil marking across. Oh, I didn't count correctly? What did I miscount? It was 3 or 4. The 1 pencil marks are off. Oh, thank you. The 4th and the 5th are here. Go mute. And I put a 5 in there for no good reason. Sorry about that. Okay, so yeah, so there's some 1s there. Now, does the world break if I make this a 4 because that also puts a 1 inside the x sum? Because if this is a 4 and a 1, I'd need these two to add to 15. That's not impossible. In fact, this 1 is always included, regardless of how I do this. Okay, let's see. Yeah, so one of those is a 9. Okay. So, I think that is the low-hanging fruit of the party. What else do we have that we can start to look at? I can pencil mark the rest of row 1. And so one tip that I will give is if you're doing 159 puzzles, you should just pencil mark everything in the way that will make Simon cry, because it's usually helpful to very aggressively pencil mark things, because very often things can't be things, and it's hard to notice if you don't carefully pencil mark stuff. In this instance, though, I don't think it did anything for us. Actually, let's look at this cell. Sorry, what can this cell actually be? It looks like it could be a 2. It's definitely not a 7. And so this is the kind of thing you're pencil marking for. Because if this is a 7, it would put a 9 there, but there's already a 6 there. This could be an 8 or a 9. I think all of that is fine. Okay. So the Jay is pointing out that these 14 sums are interesting. So so I think this one here, if this is a 3, is that a problem? Can I do a high digit, a medium digit, and a low digit? Let's see. So the lowest medium digit is 4. And the lowest high digit is 7. So 3, 4, 7 exactly works. So if I want to obey the high, mid, lowity rule and have this be a 3, this would have to go 3, 4, 7 exactly. Which is interesting because it means there's always a 4 in these cells. Because either this is a 4, or this is a 3, in which case it has to go 3, 4, 7 in order to make 14, because 3, 4, 7 already is. So this is never a 4. And so this is a 5. So I'm guessing this is the first step that tallcat intended, was to notice that there's always a 4 in these cells, and so this can't be a 4. It has to be a 5. And now these 3 cells sum to 14, which doesn't seem to immediately tell me a gigantic amount about my life. Good point from 57. This can't be a 9, because if this were a 9, I would need to make this a 6, and the 6 is gone from the row. So that's not a 9. Not a 9. Sven is still working on the listening to what you say and then pencil marking appropriately, rather than just blindly doing what you say feature for the app, which I'm looking forward to. Let's see. Let's see, is there anywhere else where we can use... So there's a similar thing happening here with the 15, actually. So let's figure out, if this is a 3 and we need to get to 15, then we get a degree of freedom, I think, because we could do 3, 4, 7 would be 14, and so we could do 3, 5, 7, or we could do 3, 4, 8. Either of those would work. Let's see. I am being told that the 19 can't have a 3 because it would need a 9. Good point. Okay, so if this cell was a 3, it would index a sum that looked like this. That was supposed to be yellow, but it came out blue, so we're going to roll with it. Which would mean that these 2 cells needed to add to 16. Which would mean they'd have to be 7 and 9, except we know the 9's over here in this box. So actually, this can't be 3. Great catch, Casey. So this is 4 or 5. Let's see. Vario says we can pencil mark 9s in box 9 into column 7, because the 24 clue with a 6 tells you these final 3 sum to 21. Okay, that's an excellent point. So just like with sandwich puzzles, if you solved those and people talk about outies, it's really useful to look at the outies of an X sum too, because every X sum actually tells you 2 pieces of information. So this 24 clue is telling us that these yellow cells sum to 24, but it's also telling us, because of Simon's secret, that these three orange cells sum to 21. And so you could try to make 21 without a 9, but if you make 21 without a 9, there's only one way to do it, which is 876. Okay. And by the way, if you're someone who really hates, and at least this is me, hates looking these things up in tables of killer things, the way you see that is to ask, okay, if I don't use a 9, what's the absolute maximum I could make these three cells add up to? Well, it's 876, which is 21. And so that means that's the only way to make these add to 21 without using a 9. But conveniently, there's a 6 up here. And so what that means is these three cells that add up to 21, they do have a 9 in them. And that 9 is not here because of this 4, 5. So one of these two cells we therefore know is a 7. I don't know which yet. The other's a 1, 2, or 3, which is putting the 9 over in one of these cells. This digit's not 9 for what it's worth. Yeah, so that gives us these. Okay, so now people are asking more about this 21. So if I now ask, how am I making 21? Well, I'm using a 9, which means the rest of it is 12. And so Barbie's point is, now I actually know what the 12 is. And the reason why is because there's only a few ways to make 12. I can't make 12 as 3 and 9 because I'm already using the 9. I could make 12 as 4 and 8, which is going to turn out to be the answer. And I can't make 12 as 5 and 7 because I just put a 7 here to index the location of the 9. So this triple we've actually learned is a 4, 8, 9 triple, with that not being the 9. But that's huge because that puts a 4 in this box, which means this is not a 4. It is a 5, which means that's a 9. And things are already happening. Let's see. We're going to continue to aggressively pencil mark. 1, 2, 3, 4, 5, 6, 7, 8. No, sorry. No 8. 1, 2, 3, 5, 7. Okay, and these are not 1 or 5. Okay. So that is that story, and that was a very productive story, all things told. Let's see. So row 8, column 7 is a 4. Why does row 8, column 7 have to be a 4? I don't see that one, Chili. Let's see. Sam says if row 1, column 5 is a 4, then box 2 won't have high digits in column 5. Oh, the 22 clue. Yes, I should look at this clue. Okay, I'll look at that in a second. I want to look at the 22 clue because the 22 clue is saying the sum of these 5 digits is 22. Well, these already sum to 14. So that means that these digits need to sum to 8. Well, you don't need to know a whole lot about sums in order to know that if I make one of the 3 digits an 8, the 3 digits aren't going to sum to 8. So this is a 4. That is a very good catch. So now these two need to sum to 4, and so they're a 1-3 pair, which immediately tells me that the 1 in this row is either there or there, which is the 6th spot or the 8th spot. So this is a 6 or an 8. I do not yet know which. Okay, so we now have our 8-9 pair going with the 7 over there. All good stuff. Okay, so now I want to go back to Sam's point that something is going wrong if this is a 4. So if this is a 4, then what are these 3 digits? Well, they do not involve a 1, which is interesting. So 4 digits not involving a 1, summing to 15. Well, 2, 3, 4, 5 already sums to 14. So this would be 2, 3, 4, 6 if I were to make this a 4. Now, the problem with this being 2, 3, 4, 6 exactly is that I have failed to put a digit that is higher than 6 in here. And remember, I need one to index the location of the 5 over in this box. And so Sam's argument, and this is really pretty, is that this has to be a 3. So now that's a 4. And so now these two digits sum to 12. And so they are not 3, 9. And so they are 4, 8, or 5, 7. I probably know which one if I think about it deeply. But I don't think I see it immediately. Now, this being a 4 is interesting, because now these 3 digits need to sum to 10 without using a 5. If I need to make 3 digits sum to 10 without using a 5, I need one of them to be a 1. So one of these cells is a 1. Index row 1. Oh, yes, thank you. Sorry. This being a 3 and this being a 4 actually are useful. Very useful, in fact, because now this 3 tells me that that's a 5 and that's a 1. Sorry, not very useful. Minimally useful, but useful because they give us two digits. I was hoping that it was going to put a 1 in here and a 5 in here to resolve both of these, but unfortunately, at least the way I counted it did the opposite. Hey, Chip, welcome. Glad to see you becoming a regular around here. Now, by Sudoku, there's definitely a 1 in one of these two cells, which means there's definitely a 6 in one of these two cells. So let's return here. So I need to make 10 in 3 cells, one of which is a 1. Because the only way to make 10 in 3 cells without a 1 is 2, 3, 5. That's just one of the ones that you know that's like the tier immediately after knowing all the ways to make 9 in a 3 arrow. But if you don't know that, by all means, don't feel bad about it. These are the kinds of things you learn by doing a lot of these puzzles. So I need a 1 plus 2 things that add together to be 9. Now, the ways to make 9 in 2 are 1, 8. It's not that because of the 1 here. 4, 5. It's not that because of the 4, 5 there. 3, 6, it's not that because of the 6 down here. And so this is, in fact, a 1, 2, 7, is the moral of the story. And now this cell has to be the 1 or the 2, because I can only put one of 1 and 2 up here. So this is a 1 or a 2, which means now within the box, one of these cells is a 1. So maybe that's the 1. Because either this is a 1 itself, or this is a 2, in which case that's a 1. Which is going to peel 1 out of the candidates over there. One of these is a 7. This digit now has to be high, because we know this digit's low and this digit's mid. So this is 7, 8, or 9 for the location of the 1. So that's saying the 1 over here is in one of these regions, or one of those cells. I don't know which yet. It's not a 7, because I already said there's a 7 in the column. Literally, I said that half a second ago. No, these are not whisper lines. These are my I'm pencil marking across boxes lines, Javier. So I know one of these two cells is a 9, so I have them corner marked. But it will cause confusion both amongst the chat and amongst my brain if I'm not careful about marking that these pencil marks are telling me one of these two cells is a 9. But it will also cause confusion because they look like whisper lines, which is granted. That's not a 1, though, because of that. So now, as Jay is now saying, I do need a 3 in this column, and I've not yet placed one. So the 3 has to go in one of these two cells, which means the 1 has to go in one of these two cells. But spoiler, it's not that one, because I already have this cell marked as 5, 6, or 7, none of which are equal to 3. So the 3 goes here, and now that dislodges the 6, so the 6 goes here. That 3 places a 1. The 6 places a 1. And now this is an 8 or a 9. And so I now know there's a 1 over in one of these two cells, and I do have an 8-9 pair that I am noticing over here, which means that this digit, in fact, actually gets upgraded. It is a 1 or a 7, because one of the 8-9 pair is a 9. I don't know which one yet. Let's see. This 6 removed 6 as a candidate from this cell. This 5 removed 5 as a candidate from this cell. And so this candidate is rather glum. It is only a 7. Not like the hippo, by the way. Different kind of glum. That 7 gives us a 1 over here. That 1 gives us a 9 over here, which gives us an 8 here, which gives us a 9 here. The 9 is indexed by a 7 here. The 1 gave us a 3 here. That one also gave us the 3 there, if you prefer. And so suddenly, just everything is just falling into place. So now we'll gratuitously pencil mark this. We need a 2, 3, 4, 5, 6, 7, and 8. Well, these aren't 7, so the only place for a 7 in the row is there. Now these two cells are 4 and a 5. Oops. 4 and a 5, which means one of these two is a 2, for what it's worth. Let's see. The 4 and the 5 I was hoping would do some damage up here, but it seems to have not done an inordinate amount of damage like I had hoped it would. But now we should probably examine this, because this is a 7-cell XSum, which means it's summing those, which means the yellow cells in total sum to 32, which means these two need to sum to 13. And now, because these two need to sum to 13, and one of them is a 5, the other one has to be an 8. So that digit's an 8. And that was Barbie who I saw first point that out. And so that being an 8 gives us a 2 and an 8 there. Everything coming up Milhouse, as they say. I'm being told a 9 in column 1 looks up. So it does. So this is an 8. That 8 places a 1. I will remember this time. I will forget it next time. Don't worry. For those of you who are here, just to point out when I fail to index things, which is a huge thing I'm very grateful for, because I'm terrible at remembering to index things on my own. Let's see. We need a 2, 3, 4, 5, 6. 2 and 6 go in over here somewhere. So that in particular, not a 2. Let's see. Interesting. Okay. So the 6 in this box is now forced to go in one of these two cells, because there can't be a 6 over here. So one of those two is a 6, which means one of these two is a 9 by index magic. Let's see. Where else do I have index magic telling me things that I'm ignoring? It's possible that that's not actually what's going on and something else is actually going on. Let me write in the rest of row 9. That's probably helpful. Okay, so we've got a 1. Yeah, okay, so we've got a 1. We need a 2, but the 2 can't go here because the 2 in this box is in one of these two places. We need a 3. We've got a 4 and a 5. We need a 6. And then we've got a 7, 8, and 9. So these are all from 2, 3, 6. Now, this is the location of the 5. So it is definitely not a 3, because 5 is not 7. It could be 2 or 6. Both of those are plausible. But now that 2-6 pair has placed a 3 here. I don't know that that's super useful, but it's not nothing. It does, I suppose, mean that there's a 3 over here in this box. Let's see. Barbie says the 9 in box 2 will help you resolve the 3, 4, 14 clue. Let's see. The 9 in box 2. Do we mean this 9? Let's see. Is it now impossible for this to be a 3? No, I don't think that's what is being communicated. Let's see. Okay, where is 9 in box 5? Yeah, one of these is a 6. I agree. I think this is one of those times where I'm being stubborn and not seeing something. Let's see. 9 in box 2 means 4 is one of the two cells in box 3. 9 in box 2. 9 in box 2 is in one of these two cells. Okay, got it. That was the thing I was not appreciating. The 9 in box 2 places the 9 here on this whisper line. So the 9 can no longer go here on the whisper line. So the 9 has to go here. It's not really a whisper line. It's my pencil marking across boxes style line. But this has now become a 9, and that becoming a 9 has made this a 3. I don't think this is how Barbie saw this. I think Barbie saw something else, but same idea, I think. Make this to be a 3. One of these is a 4, because the 9 has to go in one of these two cells. So in particular, these are never 5. So I do need a 5 somewhere, but maybe I don't know where it is yet. Okay, so now that this is a 3, I need these two to add to 11. Did I screw something up? I think I was okay. No, wrong line. What did I do? Uh-oh. You removed a couple 5 Let's see, do I need to go back? Did I screw this up? I think my point was this 9 pencil mark tells me the 9 in this box goes in one of these two, which tells me that this is not the 9. Wasn't column 5. It doesn't. Oh, sorry. I see. Okay, sorry. I now understand. Okay, so the way I did this also works, but now I understand the point about how people are getting this. So I think what I said was all completely fine. I don't think anything I said was wrong. Right? Yeah, because one of these is a 9, so this isn't a 9. So by pencil marks, this is a 9, which means that's a 3. Which is the same punchline as people are getting by saying this 9 is in column 4. So this is the argument that Barbie was making that I did not get for a long time. This 9 is in column 4. So there's a 4 in one of these two cells. So there's not a 4 in this cell. So therefore this is a 3 and that's a 9. The bit about the 4s in box 2 was wrong. Oh, sorry. Okay, I understand now. Okay, sorry. That part was all wrong. Okay. But I did want to eventually explain the argument that others were seeing. So either argument there works to get you a 9 here and a 3 here. Okay, so what's the rest of this column? 3, 4, 5, 6, 7, 8, 9. Okay, so 3, 4, and 6. That one's not a 4. So it is a 3 or a 6. I don't think I know anything about these as of yet. So yeah, so this 9 I originally tried to pencil mark here, but chat wouldn't let me get away with it. Let's see. Okay, so people are encouraging me to study carefully my pencil marks here. So in particular, as soon as I mark that 3, it strips off a 2, 5, 7 triple here. So these are not 2, 5, or 7. They are a 1, 3 pair, which just tells me what I already knew, that there's a 7 over here. Let's see. But I do want to look at the 14 clue, which Barbie is suggesting. So these need to sum to 11. So they could be 2 and 9, except they can't be because there's a 9 in the row. They could be 5 and 6, except they can't be because there's a 6 in the box. So they had better be 7 and 5 because there's not... Wait. 7 and 4. Did I do that math right now? Now I'm a little afraid that I somehow managed to screw this up. Okay. I need these to add to 11. 2 and 9 doesn't work, so this is not a 2. 5 and 6 does not work because there's a 6 there. 7 and 4 does work. So this is a 7 and 4. 2 and 5. I'm having a very good day, as it would happen. Hopefully others are as well. To answer Chip's question. 2, 3, 4, 5, 6, 7, 8, 9. That one's not a 6. This cell is an 8 or a 9. Okay, so I think this is now a situation where I think we get an elimination here. So if this is a 9, then that's an 8. And if this is an 8, then this is an 8. And so in both instances, what we learn is this is never an 8. Although I now realize that I could have deduced that this was not an 8 by perhaps looking at the 8 across the row. But whatever. I think my method of deducing that that digit was not an 8 was way cooler than looking across the row, which is very far away. Almost no one can see that far. We'll make do. Let's see. That 5 getting indexed. Yes, thank you. This 5, Navarro is pointing out, is indexed. I don't know where this 5 even came from. Came from somewhere. Means that's a 7. So this is a 5 or a 6, because I need a mid to join my high, mid, low collection. And there's a low and there's a high. So this is a 5 or a 6, which says one of these two is a 5. Let's see. So this being a 7 says these aren't 7. Now the only place, and so this is where the high, mid, low trick comes into its own. I know this digit's now locked into being a mid. I can't use another mid. So this now is forced to be an 8. And that being an 8 places a 5, not there because that's the 7th spot, but there because that's the 8th one. I have somehow multiple times thought I had broken this puzzle because I tried to place something in the wrong place because I can't count. Okay, so that being a 5 means that's an 8. This being an 8 means that's a 5. So let's see. So we've got a 7, 8, 9 to finish the column, I want to say. We've got 1, 2, 3, 4, 5, 6. Yeah, we need 7, 8, 9 to finish the column. This is not an 8, so this is a 7 or a 9. So that's swell, I suppose. This can't actually be a 9, because if this was a 9, it would make this cell an 8, and this cell can't be an 8. So this cell is a 7. So that's an 8, 9. Where is the 9 in this row going? Let's see. I've not bothered. I'm going to pencil mark these just to start. Okay, so 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are not 8. Let's see. Either of these could be 9, I suppose. One of them is definitely 4. And one of this broader collection is a 2. I don't think I know which one is a 2 just yet. If this is 9, this would be 8. This would be 2 and 4. That all seems okay. All right. Now Barbie wants me to look at this clue, and Chili wants me to look at this clue. I can probably do both of them. Chili's I see as the lower hanging fruit because these digits need to add to 15, and I know 2 of them add to 11. So this has to be a 4, which makes that a 5, which makes that a 9, which makes that a 4, which makes this decidedly not a 4, just by sort of like bouncing all around the various constraints. I may or may not have misindexed something there, but we're going to keep going with it until chat tells me otherwise. Let's see. And now this 20 clue, this is going to require more math. These add to 6, so these need to sum to 14. Let's see. Or maybe I could think about it. These need to add to 25. And that's less appealing until I pencil mark everything. Let's pencil mark everything. 2, 3, 4, 5, 6, 7, 8. Okay, somehow it's exactly the evens that are left in this column. So that is not a 4. That is not an 8. This is not a 2. Oh yeah, we always have to use the pen tool when we're marking across boxes, unless we're trying to upset people. Then we don't use the pen tool when we're marking across boxes. but I was feeling generous today, so I did not do that. Okay, this has to be a 2, 5, or 6 just by the column. Let's see. 2 seems plausible. 5 seems plausible. 6 would put a 5 here, which also seems plausible. Let's see. 25 in 4 with a 2. Let's see. 25 in 4 with a 2. Is that coming from... No, that one's just done. Let's see. This 19 clue, is that where this is coming from? I'm not sure. Okay, could this possibly be a 5? If this is a 5, the thing I'm noticing is it definitely grabs a 9, and 5 and 9 already add to 14, so the other 3 digits would need to add to 5, which is not possible because 3 digits always add to at least 6. So this is not a 5, it's a 4. And that's a 5, that's a 4. This being a 5 means that's a 2. That's a 6, that's a 2. These aren't 2. That one's not 4 either. This is a 5, 6, or 8. I don't think I know which one. Let's see. Donovan says, isn't the 20 clue 5, 7, 4, 3? Okay, that's plausible. Okay, so these 3 need to add to 14. I can't use a 2 or a 1. So the absolute minimum that these 3 can add up to is 3, 4, 6. And 3, 4, 6 is already 13. So yeah, so this has to be 3, 4, 7. Okay, so I agree, and let me go over that again just a little slower, just for a chat. So this 20 clue means I need these 3 clues to add to 14, because I already have a 1 and a 5. And so the question to ask yourself when you see these kinds of things is, what is the absolute smallest number that these could sum to? And then you hope that the answer is helpful. In this instance, the answer is 3, 4, and 6 is the smallest that these digits could be. And 3, 4, and 6 add to 13. And so the only way that this works is if I increase that number by 1, which means that these 3 cells have to be 3, 4, and 7 exactly, as many people in chat have been noticing. What's super useful about that is that this immediately becomes a 4 owing to this 3 and this 7. So now this is neither 4 nor 7, so it's a 3, and that's a 7. This is not a 4. And good job, chat, catching that, by the way. I do not usually sort of like maximize and minimize things until I am running out of other things to look at. 6 and 4, but chat is very good at doing that. I think a lot of people in chat are very good at sort of keeping an eye on mins and maxes and spotting those things really quickly, which always impresses me. Let's see. This box is missing a 2, 3, 4, 5, 6, 7. So that's not a 7. This down here now can't be a 6. Let's see. Okay, this is 6, 8, or 9, as Nicholas catches. Let's see. So, yeah, this still looks like it could be 6, 8, or 9 to me. Unless there's some combination. Can this not be 8? Yeah, this can't be 8. Sorry. This digit can't be 8, because if this digit was an 8, it would make that a 9 and this an 8. So this digit is not an 8 by that weird 159 Y-wingy sort of thing that shows up. Because if this was an 8, it would force this cell to also be an 8. So this is a 6 or a 9. Let's see. All right, and now... and this cell can never be a 6 because of this combination. This 2, 6, 7 triple that was pointed out. So in fact, per Listesh and Barbie and Donovan is also explaining this. This is a 9, so that is an 8, so that is a 6, so that's a 9. So that really goes back and cleans things up. Does all of that bookkeeping. Let's see. This 2, 7 means that's a 1, which means that's a 3. That's a 1. That 2 means that's a 6. Let's see. This is now a 2. That's a 7. Let's see. So this is not a 7. This is not a 6. This is a 2, 7 pair now. This is neither 8 nor 9, so this is a 2. So that's a 7. That's a 2. 2, 3, 4, 5, 6, 7, 8, 9 goes there. 2, 3 goes here. Let's see. These two cells are a 1, which has to go here. I at some point had corner pencil marks that told me that this had to be a 1, but I did not use them, so apologies. Oh, also this is being a 2 told me this was a 1. So take your pick, whichever of those arguments you're fond of. So this digit, 5, is a 6, which makes that a 2, which makes this digit a 3, it looks like to me. Let's see. Okay, so now probably this 19 clue we can sort out. Probably that is why Chad is telling me about the 19 clue, because now these 4 digits need to add to 19, and these add to 14, so that has to be a 5. And so that's a 6, that's a 5. That being a 6 makes that an 8. This is a 6. And then this is the very, very last cell, and it looks to be an 8. Thanks for the help on that one, Chat. Chat did a lot of heavy lifting on that one to get us there to the end. So thank you. And by the way, welcome to the new folks in chat. Very much happy to see some new faces around, as well as the familiar faces. I'm always happy to see. Oh, and we have Christoph Seeliger. So we're going to do a Christoph Seeliger puzzle next. I'm going to take a very quick break, and then we'll do a Christoph puzzle. One moment. That was by the way, this is a very lovely puzzle. This is, I think, pretty straightforward, but in a nice way, and a way that chat was all over some of the things that would have taken me a lot longer to do. By the way, those of you who are new, please consider subscribing. Also, special thank you to all of the patrons. If you're interested in becoming a patron to support the channel even more, patreon.com/zetamath is your option. I'll be right back. Nicholas says he's waiting for Fistamafel to watch one of these streams, which, I mean, it's very possible that Fistamafel does watch these streams or has watched some of them. I do not know. Fistamafel is a figure who enjoys his privacy, which is plenty fine by me. But if you're watching secretly, hello. Alrighty, so next up we have a puzzle by Christoph Seeliger, aka Real Shaggy, which is called Superfuzzy Arrows. This is an oldie, huh? I think I went through... usually when someone gives me permission to do their puzzles, I go through their LMD page and look at any notable puzzles by them that I have not done myself, which often involves pulling things out from prehistoric times, for those of you who've been posting things to LMD for a very long time. So, I'll do that. By the way, I think LMD is actually back, for those of you who have been eagerly awaiting for it to come back. Okay, so we're supposed to here follow classic Sudoku rules, so all of that's good. And then we're supposed to put a circle on each line. So we're going to draw like a circle here, for example. And then the digit in the circle is going to be the sum of the digits towards the remaining ends of the line. So basically we have made this into an arrow that has the sum of these 4 cells and the sum of these 4 cells. I should not have made both of those yellow, but whatever, it's going to be gone in a second. These would be equal in sum to those, and whatever that sum was, it would go here. All right, so basically, regular arrow stuff. Regular arrow stuff, but we put a circle somewhere. Okay, and that's it. So I'm gonna green or yellow. I'm gonna put in yellow cells that I know definitely aren't circles, that are on arrows. So for example, I can't possibly put a circle here, because if I put a circle here, what would I be saying? I'd be saying the sum of these 2 cells is equal to this cell, which is fine. But I would also be saying the sum of this one cell is equal to this cell, and that would not work. So these are not circles. For the same exact reason these aren't circles. This super isn't a circle, because if this was a circle, it would be saying that all of these... it would be saying that all 3 of these are the same digit, which would be concerning. Let's see. And so this continues here. Let's see. Chip is predicting that the bet cell is a 7. We're going to make row 5, column 5 the bet cell, because I do not have a bet cell for this puzzle. Let's see. Now, interestingly, I know the solution to this puzzle is not going to be unique, because whichever of these is the circle would work. Because all that, and this is what I think Nicholas is saying, these 2 digits are the same. All this says is these 2 digits are the same, whichever one is the circle. So this puzzle's, I think, going to have 2 solutions at the end of the day as to where the circle goes. All right. Now, we can do a lot in terms of where the circles could go on these gigantic arrows. The circle is not part of the sum, right? The circle works just like a regular arrow circle. So I certainly can't put the circle here or here, because if I put the circle in either of those places, that would be saying that this digit is the same as the circle. That'd be saying this digit is the same as the circle. Now, also, I probably can't put the circle here, because if I put the circle here, I would be summing all of these digits. And is it possible that the sum of all of these digits is less than or equal to 9? And the answer is almost certainly no, because these minimum would sum to 6. These minimum would sum to 3. That's already 9, and I can't do more, so that's definitely not there. I don't think so, Nicholas. I think everything I said was rigorous. Almost exactly the same thing I think happens here. Uh, these three sum to minimum 6. These two sum to minimum 3. So that would be 9 plus more cells. So this can't possibly be where the circle goes. Likewise, these two cells can't possibly be where the circles go. And likewise, probably, although it's less clear, this can't be the circle. Let's see. If this is a circle, what's the minimum these sum to? Yeah. Okay. So these would be minimum 9, plus we need 2 more. And I'm doing that by rows. So I'm proving this can't be a circle by showing that these digits, which is pretty clear, but I want to be rigorous about it, can't possibly sum to 9 or less. And the way I'm doing that is by breaking it down into rows. Every row here of 2 cells has to sum to at least 3. So the minimum sum here would be 12, which would probably also break Sudoku in all kinds of ways. But anyway, that can't be a circle. This one, probably the same proof works. The same proof verbatim works. This can't be a circle either. So we're making good progress out of greening things. I think we have greened all the easy cells to green now, though, I am going to bet. Okay. Now, Naverio, I think, had the key insight here, which is that if you look at these 6 cells, at least one of them has to be circled. Because if none of them are circled, then their minimum sum is 21. And 21 is too many for a sum of 2 circles, because there would be a circle over here somewhere, a circle over here somewhere, and I can't possibly make those 2 add up to 21. So actually, it's definitely the case that one of these 2, I don't know which one, but one of them is definitely circled. Usibu is pointing out that this is definitely green. I had just noticed that this had somehow escaped my gaze. But this one, if it were a circle, would put itself there, and that's not going to work. Okay. So, what else do we do to find joy in this world? Barbie says one of them is a 9, not both, but I'm not sure what Barbie is talking about. Is the point to actually consider what actually happens now that could they both be circles? Is that the question? I don't know. That doesn't sound like an appealing question to me. Okay, so does the arrow circle in box 5 have to be a 9? Is that now the question that we want to ask? Do we know there's not 2 arrow circles in box 5? You lead to a minimum sum of 10 going inward. I don't think I know what Russ means by that, but I suspect lots of people in chat are on the same page. I think they will be able to explain it to me. Let's see. Okay, so Finland says any circle in box 5 has to be at least 9. So let's see. If I put a circle here, what's the minimum it could be? Well, the minimum it could be by these 2 rows, and that box is 9. Okay, I agree. If this is a circle, it is a 9. Likewise, if this is a circle, it is a 9. Okay, I agree. So here, the argument here is just minimize this, and so I guess here, maybe it's easier to do it by region. That's minimum 3, that's minimum 3, that's minimum 3, so that's 9. And that's minimum 3, that's minimum 3, that's minimum 3, so that's 9. Okay, so one of these 2 cells is a 9, and the other is not circled. And in particular, one of these is a 1, 2. Now, I'm going to bet this one can't be a 1, 2. Because if this were a 1, 2, it would make this at least a 3, 4. No, I guess that's okay if this is the circle. Sorry, I was hoping it would immediately push this arrow to be too big, but I don't think that it does. But the fact that it is the case that one of these does have to go 1, 2, 1, 2, 1, 2 is assuredly relevant. Let's see. One other way to see it is if all of these are 1, 2, it does force both 1 and 2 to be up here. Oh, that's okay. That does it. That does it. Okay. So, no, sorry, that doesn't do it because I'm talking about. Because I'm talking about that one having the circle and this one having the circle, and only one of them, of course, has the circle. Anyone else having problems? Chip says that they're stuck at 144p. Is anyone else having issues with resolution? You should be able to click the link and read the rules, but sorry about the resolution issue. That is not ideal. Okay. I think maybe the key is this digit. No, I really don't think so. No, that's not it. Yeah, so if this is the line that has just a jajillion 1, 2s on it, then it does force 2 1, 2s up here. But that would be okay, it looks like to me. Yeah, there's some connection here that I'm not seeing with the X swing on 1, 2s that we're going to get. Let's see. Oh, interesting. Okay, so Barbie says these green cells are always 1, 2, no matter where the 9 is. Well, if that's true, then the 9 can't be the one that looks here. Because if the 9 is over here, then we're kaput. So this is definitely a 3-cell arrow. Oh, are not 1, 2. Sorry, not 1, 2. I'm not good with negatives. Let's see. Okay, Russ is saying both row 3, column 8, and row 7, column 2, must be green because they lead to a minimum sum of 7 going inward. Okay, so let's count. So what's the minimum sum if this spirals inward? So if in the universe where this is a circle, well, this would be minimum 1 plus 3 is 4 plus 6 is 10. Okay, I agree. Because there would be 3 cells on this line in this box, and then 1 and 1, 2. Yep, so that is green. Totally agree. Great catch, Russ. Sorry, I did not see it before. And row 3, column 8, same thing. If I tried to make this a circle, it would be 1 plus 3 plus 6, and that's 10. Okay. Ooh, I'm on the big screen. Fancy. Like a movie star. Let's see. Okay, so we've got lots of greening now. let's see. So this column already has 4 green cells. And that's gonna be awfully hard. So could this cell ever be green? If this cell is green, then the maximum these 3 cells sum to is 9. So the minimum these 2 sum to is 6. So yeah, if this cell is green, then these 2 sum to at least 6. And so this would go 6. And then I guess if the circle was here, maybe it would be okay. Could the circle be here? I think, unfortunately, the circle could be here. Darn it. I'm suspicious of that, but I don't think I can prove it does not work. Let's see. So yeah, this is a 3-cell arrow. So whatever way this goes, this is a 3-cell arrow. It needs a 1 or a 2 on it. And so one of these 2 cells, whichever one it is a 1 or a 2, because I either have a 1-2 pair in both of these places, which would force that to be the 1-2, or this is a 1-2 pair, which would force that to be a 1-2. But I can't make an arrow without a 1 or a 2. So, and there's no great way to pencil mark this. One of these 2 is a 1-2. So yeah, if these are 1-2, that's 1-2, that's 1-2, and that's 1-2, and then I have to put a 1-2, I guess, up here in one of these places. Let's see. Usubu says row 2, column 7, and row 8, column 3 are green. Let's see. If this is the circle, then row 4, column 4 is a 9. Sorry. If this is the circle... Sorry, let me do this the right way. If row 8, column 3 is the circle, then row 4, column 4 is a 9. I agree. So if this is a circle, that's a circle. And then there would be too many 1-2s in column 5. Okay, so if this is the circle, then that means these are 1-2s. And now, these are 1-2s. These would have to be 1, 2, 3. And so this would have to be 1, 2, 3. Okay. Beautiful. Okay. So I think I have to actually draw this out. Okay. So if this, and I'm going to get rid of the bet cell. I'm going to make the bet cell an X just to avoid confusion. If this is the arrowhead, now I just have to look at this and say, so now the minimum this can be is 1, 2, and 1, 2, 3, and that makes 9. So that would have to be exactly what happened. But now remember, this arrow here has to be 1, 2, 1, 2, 1, 2 the whole way. But now that means I've put a 1, 2 here. I've put a 1, 2 there. And I've also put a 1, 2 here. Wait, is that too many 1, 2s? Okay. So, yeah, there would be... Okay, so between these 2 columns, how many 1, 2s is that? And so that's 2 1, 2s up there, 3 1, 2s down there, and then 2 more 1, 2s here. That's 5 1, 2s in 2 columns. And 5 1, 2s in 2 columns is too many 1, 2s for 2 columns. I don't think I can pinpoint which column has too many 1, 2s, but the 2 together definitely have too many 1, 2s. And so the punchline is this is never a circle. It's green. And now the argument should be completely symmetrical if we look at this cell instead. So if this cell was a circle, let's go through this again slowly and make sure. These would be 1, 2, so that would be 1, 2 in particular. These would be a 1, 2, 3, so 2 of these would be 1 and 2. And then this would be a 9, so both of these would be 1 and 2. And so that would be a 1, 2 pair, a 1, 2 pair in here somewhere, and then a fifth 1, 2, that's too many. So that is also green. Okay. So that narrows in that, well, one of these is the circle, of course. Then the other circle goes in one of these two places on either side. I don't know which side yet. This one I keep eyeing with suspicion because it could well be that this is actually saying there's a repeated digit between these two cells. I do not know. Okay, so Typon says that means that the other circle has to be in column 5. Okay, so let's see. Why will it not work if I put it in column 4? So if I put a circle here, for example, what's wrong with putting a circle here? The circle would have to be at least 6. In fact, it would have to be at least 7, actually, I suppose. Oh, wait. Okay, sorry. I think I can do this. Okay, so if this is the circle, okay, I think I can explain this. If this is the circle, I think this is what Typon is seeing. Then that means that these... Sorry, I didn't mean to be in pen tool still. That would mean that these are a 1, 2, which would put a 1 and a 2 up here. No, I don't, never mind. I don't, oh. Wait, do I know that this other circle's a 9? I'm trying to prove the other circle has to be a 9. If the other circle has to be a 9, then I think I believe Typon's point, because this would be the 9. But I don't think I see why this has to be 1, 2. I'm trying to sort of chase the 1, 2s around to bully this total up a lot, but I do not yet see it. So you still need to put a 1 or 2 in row 7, column 5, says Jay. If I put the circle here, okay, let me chase that idea. Okay, so let's say I put the circle here. Then I know that these are 1, 2. Now, I could use, yeah, and so I know now that the maximum, yeah, okay, so the minimum value of these 3 cells is 6. This can't be a 9, so this would have to be a 1 or a 2. Yeah, circles can be in the same column or row or whatever. Hey, Yoshi, welcome. Not sure if I've seen you around here before, but welcome, Yoshi, either way. I'm glad to see you in chat. Yeah, there's no Sudoku rule on circles. I think it might just work to have this be a 9, or sorry, not this be a 9, this be an 8 with a 2, and then a 1, 2, 3 over here. No, that doesn't work. Okay, actually, sorry. I think Jay's point is correct. Okay, so if this is a circle, this can't be a 9, so it's at most an 8. So this digit is a 1 or a 2. But now these are already 1, 2, because remember, all of these are 1, 2. But now what if I don't use both 1 and 2 here? Well, then I could use 1 and 3, 4, say, but now I'm already summing back to 9 again. So that doesn't work. So I agree with the combination teamwork of J and Typon that actually, yes, that this can't be a circle, and for the same reason this can't be a circle, because in order for that to be a circle, this cell has to be a 1 or a 2, which then puts too many 1s or 2s. Okay, so now the other circle is in one of these two cells, for whatever good that is going to do us. Yes, so that would be 5 1-2s in 2 columns. You can't put 5 1-2s in 2 columns. That will not end well, at least in this puzzle. I worry I might be putting 5 1-2s in a lot of pairs of columns come Wednesday, but we'll get there when we get there. Oh, I did not reset the timer, so it's currently saying I've been working on this for 3,000 minutes. Okay, so Nicholas is row 7, column 6. Cannot be less than 7. I don't see why. What does row 7, column 6 have to do with anything? Am I counting correctly? We know, Jay, that both circles aren't in box 5. There is no way that both circles can be in box 5 because we proved, and this is not at all obvious, by the way, Jay, but we proved that if this is a circle, it has to be a 9 because these would have to be 1 2 1 2 1 2 1 2. That's the absolute minimum I could make these, which would make this a 9. The same is true over here. But then if I tried to put both circles in box 5, I would be putting 2 9s into box 5, and I cannot put 2 9s into box 5. So that is the logic as to why we know that both circles aren't here. So one circle is in one of these two cells. I don't know which. And then one circle is in one of these two cells. Yeah, so so maybe it's worth asking, okay, yeah, the minimum value of whichever of these is a circle is, as Nicholas points out, the minimum value of this, whichever of these is a circle, is 7. But I don't know, Nicholas is saying row 7, column 5, but I don't know that that's the one that's the circle. It could be row 3, column 5. Yeah, I feel like for 3,000 minutes in, I don't have a lot of pencil marks in the grid. But whichever of these, yeah, I agree, whichever of these is the circle, however it works out, it has to be at least 7. But then the other side is, of course, a 1 or a 2. I think almost certainly the 9 that is in 2 cells is going to have to be as a 4 5. Well, the other is a 1 or a 2, Nicholas. So one of them is at least a 7, and the other is a 1 or a 2. So yeah, one of these 2 cells is a 1 2, and then the other one is a number that's at least 7. Oh, here's another observation. No, I don't think it's an observation. Let's see. The green cells in box 1 and 9 have to be 3 4 5. You mean 2 3 4? Barbie? Yeah, so let's say the circle's here. If neither of these was a 1, then these would sum to at least 5. These would be... so I'm just imagining the universe where this is the circle, and I'm trying to see if I can prove there still has to be a 1 here. So if there's no 1 here, the absolute minimum I could make would be 2 3 is 5, 8, 9. And then this would be another 9. But that's not going to work. Okay, let's see. Usibu asks, why can't row 8, column 8 be a 1, 2, if row 4, column 4 is a 9. I don't think I know that. Oh. These cells. Okay. Got it. Okay. This is beautiful, and I'm sorry I did not see this sooner, Barbie. Okay. There are two universes. In one universe, these cells, which I'm going to temporarily make yellow, are two sets of 1, 2. In the other universe, these cells are 1, 2. That means these two cells here are always at least 3. And so these cells are always... Sorry, I did not at all appreciate this. I kept trying to get it. These are always 3, 4, 5. There's just no way for them to not be 3, 4, 5 because of that. So this is a set of 3, 4, 5, which means the other digit on this line has to be a 1 or a 2, and the digit in the circle, wherever it is always an 8 or a 9. So you could pencil mark it like this if you want. Okay. And so they have to contain a 3, as Usibu points out. So they have to contain a 3. That is a good point. Okay. So now let's look back at the universe where this is a circle. So if this is a circle, we now know these don't contain a 3. So these can't be a 1, 2 pair. So Ambrose, the point is the 1, 2 pair are either here or here. But if the 1, 2 pair is here, then this cell does not see the 1, 2. It's a little complicated because of the strange nature of this. So is something symmetrical happening? I guess the symmetrical thing is happening to this cell specifically. This cell can't be a 1 or a 2 because it sees either an X-wing over here or it sees this directly. So this is always a 3, 4, 5, 6. Okay, let's see. Christoph says, can row 3, column 2 be the circle? So if this is a circle, then these sum to... okay. So now I think we are cooking with gas. Because if this is the circle, so this is the universe that I hope we're going to be disproving, then these cells now have to sum to at least 15, which means that these two cells sum to at least 6. Now, if these two cells sum to at least 6, then these are at least 9 in total, which now means that these sum to at least 10, which means this can't be a circle. But now that's a big problem because in putting this circle here, we have actually said that this isn't the 1, 2. Wait, no, this is the 1, 2. Oh no, I've lost it. Okay, one second. Let me try and articulate this in a way that I understand. Okay, so either the 9 is here, in which case this is a 1, 2, and this is the circle. That's one option. Wait, no. That's the good version, right? If this is 1, 2, we want this to be the circle. No. No. Okay, sorry. The 9 is in one of these two places. If the 9 is here, this goes 1, 2, 1, 2, 1, 2. This can absolutely not be the circle, because if this is a 1, 2, then this would be 3, 4, 5 at minimum, and this would not be able to be the circle. Okay, so this can't be the circle if the 9 is here. What if the 9 is here instead? If the 9 is here instead, then now these are my 1, 2s. And now this is the circle. This is a 1 or a 2. But now I have to look at, remember in this instance, the circle is here for the other line. So now these two cells sum to at least 6 because we've had to put the circle here. These sum to at least 6 plus at least 3 is 9 plus at least 1 is 10. And so that breaks. Okay. So I think the thing we just broke is to say this is never a circle. Because as soon as this cell is a circle, we force the following chain of unfortunate events. All of these become 1, 2. This becomes a circle. This becomes a 1 or a 2. But in particular, these cells sum to at least 15. And so these two sum to at least 6. But these two can't sum to at least 6. Because that would make the sum of these along here at least 10. And remember, when the circle's here, it also puts a circle here. And so this circle now has to contain a digit that's at least 10, and that doesn't work. So that's not the circle. This is the circle. I think that is the punchline. Was that the intended argument, Christoph? I think that is what we have concluded. Okay, so this is not the circle. This is the circle. That's not a thing. So that's a 9. And then we get to do a digit dance. And now, once we have this as being the 9, we of course now know that's not a circle. And now this one goes 1, 2 all the way over here, which now forces this to be the circle. This now, oops, sorry, wrong tool. This now is a 1 or a 2. It's not a circle. So this is a 1, 2 pair. Okay, now this sum, this digit has to be at least 3 for whatever that's worth. Okay, so now let's look over in this box. This 1, 2 pair sees this. So this had better be a circle, because if this is not a circle, then this arrow now sums to at least 3 plus 4 plus 5, which is way too many. I don't think I can add that many numbers at this particular juncture in my life, but that's not going to work. Okay. In particular, these digits definitely are still, it's true, at least 3, 4, 5, 6. Now, 3 and 4 already add to 7, which forces this to be a 1 or a 2. So this is already known to be 7, 8, or 9, for whatever that's worth. Yeah, what is this sum now? I don't think I know yet. Yeah, okay. Barbie points out wisely, I can't put a 6 here, because if I put a 6, I'd need a 1 and a 2, and that doesn't work. Or put a different way, if I do put a 6 here, what's the minimum I can make this arrow sum to? Well, it would be 6 and 3 plus something else. That's not going to work. So either way, the punchline is these are actually from 3, 4, 5, and per Taipan's point from earlier, they always contain a 3, in fact. Because if I tried to make them 4 and 5, that's not going to go well. Okay. Yeah, good point. Usibu has this. This is always a 1 or a 2, because the absolute minimum these two sum to is 7, so this can never be bigger than 2. In fact, this can't be 7 either, because if it was 7, this would need to be a 0. So that's not great. So the minimum sum of these cells, since there's a 1, 2 here, the minimum sum of these cells is 4, because I can't use both a 1 and a 2. So that's 4, 7, 8. So this cell is an 8 or a 9, for what it's worth. And I can't put anything more than 1 degree above that. So the minimum was for these to be 1, 3. So these are from 1, 2, 3, 4. The minimum was for these to be 1, 2. So the absolute maximum they can possibly be is 3, and the minimum for this one was 1. So this can be a 1 or a 2. So this is just writing down our degrees of freedom, and in particular, I always have to have a 1 in these cells. If I don't have a 1 in these cells, then I've gone from my minimum of 1, 2 up to 5, and I don't have enough degrees of freedom to do that. So one of these is always a 1. Okay. Let's see. Sibu says row 3, column 8 is not a 3. This is where 3... okay, yeah, that's weird. I see it, but this is weird. Okay, if this is a 3, then by my argument about degrees of freedom, this would have to be a 1, because the minimum here is 1, 2. And so if this is a 3, that has to be a 1. But then that makes this a 2, which eats up a second degree of freedom. Wow. That is quite a spot. Okay, so this is not a 1 or a 2. Or sorry, this is not a 3. It's a 1 or a 2, because it would eat up 2 degrees of freedom if it tried to be otherwise. So we now have a 1, 2 pair in this row. Let's see, the same argument can be made with row 2 or box 3. I'm not sure I understand what the same argument is here. Let's see, Nicholas is asking about where the arrow is in row 1. It's certainly in one of these two places. Let's see. If I don't think I quite see it. Oh, I see. Okay, you're suggesting a different way. When you said the same argument, I was thinking that I was thinking you were saying I could remove more digits, but you were saying a different way of seeing the same degrees of freedom counting. Got it. Okay. Oh, sorry. Nicholas isn't talking about row 1. Nicholas is talking about row 9. Yeah, one of these is a 7, 8, 9. Whichever one's the circle. It's interesting. I have to put a 1, 2 in one of these cells. It's certainly not that one. I have to put a 1, 2 in one of these two cells. I'm trying to look at these arrows as well. But I don't think I have a story to tell about these arrows yet, as much as I would like to. Unfortunately, we could just get away with making this a 1 or a 2 and making neither of these a 1, 2. I would really like to prove that one of these has to be a 1, 2, because then that would have some carry down effect over here by looking at these 1, 2s as well. I guess it's worth pointing out one of these is a 1, 2. But I don't think I know which one is a 1, 2 yet. Let's see. I darn near have a quintuple here, actually. So what happens if I make this not a circle? If I make this not a circle, then I make the sum of these digits at least 21. Is there any universe in which the sum of these things is allowed to be 21? Because this would be at least 4. Sorry, I guess I should say at most. This would be at most 6. This would be at most 4. That's 10. This would have to be 11. No, that doesn't work. This pair of cells is at most 4 by our degrees of freedom argument. This pair of cells is at most 6 by whatever you want. So if this was not a circle, these would have to add to at least 11, which is not possible. So this is a circle. And that's not a circle. Okay. Now, this circle actually has to be pretty big because of the fact that there are 3 arrow cells in row 1. And the fact that there are 5 arrow cells in row 1 means that both arrows in row 1 have to sum to together at least 15. And since the most any one individual one can sum to is 9, the other has to be at least 6. So this cell is at least 6. Could I do better by knowing that 1 is gone and 1 of 2 and 3 are gone? Maybe I could do better by looking at the box. So 2 and 4. No, in fact, I do exactly the same by looking at the box, suspiciously enough. Now, maybe I can figure... Can I still restrict this digit? Does this digit still have to be fairly small? This is at most 5. Sorry, no, these are at most... These are at most 5, because again, the minimum is 4. These are at most 5. These are at most 6, so that's 11. So this cell has to be at least 4 in order to get to 15. But this digit is at least 2, so this digit can only be from 4, 5, 6, 7. That does not seem very helpful in terms of things that are helpful. Okay, Kurban wants to rule out a circle from this cell because if this cell were a circle, these 2 digits would have to be at least 3, 4, and this digit would have to be at least 3, 4, and that's 3 digits that are all at least 3, 4. So this is definitely not a circle. I agree. 1, 2 pair looking at this cell, 1, 2 pair looking at that cell. So let's see. If this were the circle, these would have to each be at least 3. I don't think I quite know enough about this one to break it, though. Hey, Ranksk. Welcome. So it's arrows, but you can put the circle wherever you want, but only one circle. Let's see, Nicholas is looking at row 1, column 9. Okay, I think Nicholas is saying that Nicholas does not like one of the options that I put here. I would believe that this can't actually be as high as 7. This being 7 seems incredibly unlikely to be true, but I I was really more interested in the lower bound, but I didn't want to pencil mark something that was not correct. So I actually have an 8-9 pair virtually in this row, because whatever this circle is... Oh, maybe that's not true? Question mark. Does this circle have to be at least 8-9? Maybe it doesn't. I do feel like I should be able to deduce something about the arrows in this box, but the 1-2s are just not quite lined up in such a way to help me do that. Can row 7, column 7 be a circle? I think row 7, column 7 had better be a circle. I mean, I don't know. It might not be a circle, but I think this being a circle is way worse. If this is a circle, now I've got a sum here that's already huge. Yeah, there is a 7, 8, 9 on whichever side of this is going to get its circle. Whatever this digit is, I'm just saying things I know. Whatever this digit is, it's up here somewhere. Okay, is it possible for me to rule out that this is an 8? Like, is there something wrong with the world where everything here is minimum? Maybe that's a smart thing to ask. If everything here is minimum, that is, if this actually is an 8, this sells a 1, this sells a 2, that sells a 1, and this is a 1-3 pair. So that would be the 3. I don't see anything immediately clearly wrong with that, unfortunately. So this digit's at least 4. Maybe that's worth noting. It's certainly not a 9 or an 8. Probably not a 7 either. But I'm more interested in the fact that this digit's actually at least 4, because it sees the 3 over here. So this digit's at least 4. This digit's at least 3. So if this is the circle, actually, this has to be a 1 or a 2. Is that a problem? Because there's a 1 or a 2 here. We'd have used the other 1, 2 here. Don't quite see it. Let's see. Barbie is looking at row 9, column 5 can't be the circle. I really don't believe this could be the circle, but I just can't quite get there. This is at least 4. This is at least... Oh, this is at least 4. This is at least 4. Sorry, I missed. There's a 3 in this box. That's the key. So this cell is also at least 4. And so if this is a circle, this has to be a 1. Now, does that break? If this has to be a 1... This would have to be 2, 3. This would have to be 2, 1. And that doesn't work, because now this has to be a 2. No, maybe that's fine. That just makes this a 9. Oh, but that makes this a 9 too. Wow. Okay, that's really complicated. Okay, but I can see it. Okay. So this is Barbie's point, and it's very well spotted. If... pen tool's not being cooperative. If this is a circle, this circle has to be a 9, because this cell is at least 4. It sees 1, 2, 3. This cell is at least 4. It sees 1, 2, 3. So this cell has to be a 1, and this is a 9. But now that has a cascading effect that's going to break this cell. Because keep in mind, these two cells see each other. So this now has to be an 8 in the universe where this is a 9. But it's not going to be, because once this is a 1, these are at least 5, plus at least 3, plus at least 1 is an 8. Doesn't work. So this is not an arrow. Or sorry, this is not a circle. So this is the circle. Sorry, Nicholas. So now that this is a circle, it is at least 7. No, it's not at least 7. It's at least 7. At least 7's right. Because these are at least 3 and 4. 3 would have to go there. Now this can't be anywhere near that high, because this is at least 3, so this can be at most 6 if this is a 9. I might be able to do a touch better there. I know it's not a 9, because this digit is the same as this digit by arrow logic, and this digit's definitely not a 9, so this is not a 9. Yeah, so these two are the same, and I'm putting this digit in one of these cells over here. Yeah, Christoph is pointing out, and this is sort of the argument. When I re-summarized the argument was better. Christoph has the smart way of saying it, which is it places a 1 here, which eats the degree of freedom, and as soon as it eats the degree of freedom, this is already a 9, and we're already broken. So if I remember the sort of the degrees of freedom thing, it just immediately breaks. So Christoph is completely right. Welcome, Yab, by the way. I'm not sure if I've seen you chatting before, but Yab says if any number is minimum in that long line, there would be 2 9s in row 1. If any number is minimum in that long line, so you're saying, like, if this is a 1, okay, I think I believe this. So if this is a 1, then that's a 1. Sorry, I'm trying to get here. It's a little tricky for me to see. But I think the point is both of these arrows... Okay, so if this is a 1, that's a 1. Now that makes that a 2. So this arrow is a 9. So this arrow now has to be an 8 or less. So that would have to be a 1. These two digits... and here's where I can't quite see the follow-through that forces this to be a 9 once I've made that a 1. I think I believe that if I saw what Yab is seeing, I would see it, but I don't quite see it. Let's see. Barbie says row 8, column 7 is always a 9. Let's see. If you put a 7 there... okay, so if this was an 8 instead, it would put a 7 there and there. This would be an 8, which would make that a 1, with a 3 and a 4. And now this would have to be at least 5 or 6, but that's a 1. So this would have to be at least 3, and that's okay. Good spot, Barbie. I would not, I think, have seen this. Okay, so in the world where this is an 8, this arrow is a 7. But that's going to be a huge problem, because this arrow is going to actually be enormous. Because if this is an 8, then this needs to be a 3, 4, which means that this cell's at least a 5, adding to this cell that's at least a 3. But that doesn't work, because we just said 5 plus 3, which is 8, but this was a 7. So this is not an 8. It is a 9. Great spot to Barbie for that one. Okay, so this is a 9. Is there any way we can sort of amortize that into saying that this digit's always an 8? Well, this can't possibly be a 6. I can get you that far, because this digit can't be a 6, because if this were a 6 plus 3, that would be at least 9, and this is not at least 9. So this digit, in fact, gives us a 3, 4, 5 triple in the row. So actually, we can fill in the rest of the row, because we have 1, 2, 3, 4, 5 now. So this is 1, 2, 3, 4, 5, 6, 7, 8 is what these digits are to fill out the row. Now, if this is going to give me a 7 or 8 with a 4 or a 5, well, a 5 would need to go with a 2 or a 3, and a 4 would need to go with a 3 or a... Well, the 4 would not. The 4 would need to go with a 3, because the 4 couldn't add to 8 with a 4. And as Christoph now points out, we have a 1-2 pair in box 8, so this can't possibly be a 2. It is a 3. Okay, so this digit actually is, in all possible universes, it's always a 3. Which now has forced there to be a 9 on this arrow, because now this arrow can't have a 1, 2, or 3 on it. So one of these two cells is actually a 9. Which now places a 9 here, because now if I look at row 7, I have my 9 over there, I have my 9 over here, that 9 sees that 9, so that digit's a 9. Now, that puts a 9 in exactly one of these two cells, for whatever that's worth. Yeah, I Changeable points this out and spells this out. What I basically just argued is this has to be 459, and then I didn't actually write it down. So this is a 459 triple. So this cell, therefore, has to be 4 or 5, which tells us something huge. Okay, because this 459, it has to go somewhere in this box. Namely, the 4, 5, and 9 have to go in now these three cells. But now that tells us this 9 arrow is not a 4, 5, which is what I've always assumed it was going to be, but it's not a 4, 5. So this 9 arrow is... Do I know what it is now? Or do I just know it's not 4, 5? I might just know it's not 4, 5, but that still seems large. To me, at least. Let's see. Okay, so... There does have to be a 3. In fact, there has to be a 3 in this box, and as is pointed out by Kurobon, it has to go exactly here. And scanning back in chat, Nimuzaki actually also said this digit has to be a 3. Nimuzaki, sorry, I did not read your name. Not only did I not pronounce it correctly, I did not even read the letters correctly. Nimuzaki said this also pointed out this now is the only place for a 3. So this is a 6, 7, or 8. No problem, tallcat. Happy to have you back. Okay, so what are these digits? I still need a 1 and a 2. I've got a 3, 4, 5. I need a 6, 7, 8 down here. Of course, these are not 1 or 2. They are 6, 7, or 8. Yeah, so one of these is the 1, 2. Post-escape room shenanigans. I mean, I presume the people who don't get out of the escape rooms just never report. It's like a survivorship bias sort of thing. Okay. I do my best with screen names, but it is very difficult because I look at them and then I do not identify the letters correctly very well. Let's see. Okay, so Ranks has a delightful suggestion, which will probably... well, I'm not actually sure if I'm optimistic it'll help, but I'm very optimistic it'll be fun. which is that we can color the 1 2s. So these 1 2s, so the black 1 2, I don't know what it is, but it's always the same digit. So that 1 2 is going to hop up there and tell me that that's the blue 1 2. So that's the black 1 2. Does my coloring continue after that in some way, shape, or form? Let's see. Nicholas asks if row 3, column 5 can ever be an 8. If this were 8, this would be 1 3 4. No, I mean, it was a great suggestion, Ranks. It sounded like there was a chance it would do something. Plus, it was fun, so, win-win. Except for the Sudoku part. It did not win on that front. But on all other fronts, it was a win. Let's see. So this would have to be 1 3 4, and then the 9 would be, it can't be 4 5. It would have to be 2 7, if this were 1 3 4. Do you see why this can't be 1 3 4 and 2 7, Nicholas? There's a key insight about the 1 2 3 pair in box 2 and 3 that is missing. It probably involves counting degrees of freedom in some way. So if this were blue, this would be black. I don't know if that's helpful. Let's see. Should I ask about where black goes up here? I know that the black 1 2 goes in one of these 2 cells. Nine in box 6. The 9 in box 6 I can at least say is in one of these 2 cells. Thank you, Kurabon. Sorry, thank you, Yab. So now I know the 9 over here is in one of these 2 cells. Which does give me an X-wing on 9s. So I know one of these is a 9, and I know one of these is a 9. Which tells me that one of these digits is a 9. Yeah, there's got to be something that eats 2 degrees of freedom at once. I think that's what Christoph is hinting at, is that if I am not careful, I'm going to eat 2 degrees of freedom at once on one of these. If row 2, column 6 were blue, then it would make row 2, column 7 a 3. So then blue would have to be 1. So Ranks is following the coloring. If this was blue, then this would see both flavors of 1 2, and so it would have to be a 3. Oh, no, that doesn't work. That doesn't work. Okay, great. Okay, so Ranks has made the insight, which is, I think, the insight Christoph was looking at. If this is blue, now this is a 3, which means now both of these are 1, except they're different colors. This is 1 because we've already used our degree of freedom over here, but now this is 1 because we've already used our degree of freedom over here. Okay, so that means that this cell is actually black. Okay, which means this cell is black. And that has to be the key. So now just look at black in row 1. It can now only go here. So that's not the 9. That's the 9. Okay, that is really clever setting. I really like that kind of game with the coloring. Uh, and so now, now is going to be one of the times where it's going to refuse to pen tool for me. There we go. Why can't row 1, column 1 be a 9? Oh, sorry. Row 1, column 1 can be a 9. Never mind. Sorry. This can't be a 9, though. Sorry. Good point. I had another option for 9. Sorry, you're right. You are completely correct. Okay. Now my blue digit doesn't go in any of these places. Ah, okay. And now this has to be the blue one, too. Because I can't put the blue 1, 2 on the palindrome, because if I put the blue 1, 2 on the palindrome, then I repeat it in a box that already has a blue 1, 2. And everywhere else in this box already couldn't be a blue 1, 2. So that's the blue 1, 2. Okay, so these are a 1, 2 pair, which now means this digit is at least 3. And now that means this digit's not 7. And that means this digit's not 6. Because this is now 3, 4, 5. 3, 4, 5. Those are the options. Okay. This digit is not a 3. So this digit is at least 4. So that means this digit is at least... Sorry, that means this sum is at least 7. But it can't be 9, remember. Because we already have our 9 living over here, or a 9 looking at this, or whatever form of reality you prefer. So this is a 4, 5. Which, as Ranks points out... No, I don't quite see it. Oh, sorry. Ranks was just echoing what I said. Sorry, I was thinking this 4, 5 was going to mean that this sum couldn't be 9. But this sum can be 9 still if it's 3, 6. Yeah, this... So Barbie is pointing out these two digits are those two digits. So this digit's always a 7, 8, or 9. And that's because this digit is that digit by the palindrome. And so that digit also gets pushed into these two cells. So that is what ruling 7 out of this cell did for us, or one of the things that ruling 7 out of that cell did for us. There may be others yet to come. Okay, so can row 3, column 5 be an 8? So if it was an 8, this would need to be 1, 3, 4, because I can't use both 1 and 2 on it. This would need to be black. In fact, I know I need to use 1 or 2 on this cell. Every arrow of length 3 needs a 1 or a 2. And so these can be neither 1 nor 2. So this is the black 1, 2. So that lets us do a little more coloring. Blue and black. I think that this might get us to Nicholas's point. So now... this could only possibly be an 8 if this is a 3, 4 pair. And now this 9 would have to be a 2, 7, which still seems okay to me. Let's see. Ranks believes that row 1, column 8 is always a 3. Sorry, column 8 is always a 3. Let's see. I can't put a 3 here, so I always need to put a 3 in one of these two cells. And if I put the 3 here, what happens that goes wrong? Yeah, if I put the 3 here, yeah, okay, so yeah, I can give Rank's argument. There's no 3 in these cells because there's already a 3 in this box. There's no 3 in these because there's not one pencil marked anywhere. So one of these two is a 3. But if this is a 3, then this is a 4 or a 5, and this is a 4 or a 5, just in order to make this arrow not break. But that breaks this cell. That is really clever. Good spot, Ranks. So this is not a 3. That's the 3. So that's blue. Sadly, that doesn't tell me anything down here, but it does let me place a 3 there. So that's not a 3. On the bright side, we might get to color 4 5s, so you can be excited for that. But that proves Nicholas's claim, because now we've eaten our degree of freedom, because this needed to be a 1 3 in order for this to be an 8, and this can no longer be 1 3. So now this can no longer be 1 3. And hence, this is 1 4, in fact. And this is a 9. And that is going to disambiguate everything. Let me do the coloring first. Can I? Let's see. Okay, so now this is 1 4. So black needs to be 1 in order for that to work out. So black is 1, blue is 2. Yeah, this is a very cool puzzle. So this is not black. This is black and is a 1. This is blue and is a 2. This has to be a 4, otherwise math breaks. Let's see. That's still a 2, as Ranks points out. I don't know how it got lost when it was getting swept up in the excitement of everything. These aren't 2 anymore. Can confirm. Let's see. Has that placed any of our 9s that we knew about? No, it has not placed any of the 9s that we knew about. Let's see. Row 8, column 8. Looks left. Got it. Okay, thank you, Jay. This 4 now makes that a 5, which makes that an 8 and that an 8. Which makes these not 8. Makes these not 8. No, sorry. Makes that not 8. That being a 5 makes that a 4. Means I do still need a 5 in one of these two cells. I don't know which one yet. That's not a 1 because of the 1 above. The only place for a 1 now in row 9 is there, which probably could have been said better as 1 gets placed by Sudoku in the box there. Do I have all my 1s now? Yes, I have all my 1s. Do I have all my 2s? I don't yet have all my 2s, but I probably should have all my 2s. One of these is a 2, so this is actually a 2-9 pair. And one of these two is a 2. Okay. If that's a 2, then that's a 7. If that's a 2, then this is a 3-6. Okay, these two cells, actually, maybe I should ask about these two cells. These two cells need to add to 8 without being a 1-7 or a 2-6. So these two cells need to be a 3-5 in order to make that arrow work. And now, once I've used 1, 3, and 5, this arrow is now forced to be a 2-7. It has no choice. So that's a 2, that's a 7. The 2 looks over here and says that's a 9, and that's a 2. So that is cool beans, as they used to say in like the 90s, back when I'm from. Let's see. So 1, 2. We still need a 3. Actually, the 3 we need goes here because there's already a 3 in this box. So this digit's a 3. Oh, no, there's a 2 I did not blue. I'm sorry. Ooh, this one didn't get blue either. It inherits an extra green just so that it matches its friends. It wants to blend in. Uh, so this is a 6, 7, or an 8, but it's not a 7. So this is a 6 or an 8. Let's see. What is missing in the box? 1, 2, 3. These are 4, 6, 8. The bet cell is a 6 or an 8, so that's a 4. Okay, so the bet cell is a 6 or an 8. Whose bets are still live? Who remembers what they bet? But the thing is, and I'll tell you this, and this works in ranked stream as well, probably no one remembers what you bet, so if every time you claim at the end that that was what you bet, probably no one will catch on for a very long time, especially if you do it very judiciously. And especially if you don't actually ever bet. 5, 6, 7, 8, 9. So that's a pro tip for people who are into the bet cell game. Let's see. This is a 5, 6, or a 7. This may be why my colleagues call me an anarchist. Let's see. Logan said 8. Ooh. Oh, now Directionary is disproving my point by suggesting that Directionary might actually police you if you misclaim what it is that you bet. Let's see. Kurban says row 8, column 5 is a 6. Well, it's not a 7. That's not a 9 anymore. This 9 placed a 9 over here. So that's a 6. So that's not a 9 anymore. I realized I got distracted in the process of all of this. Yeah, I see that Directionary is maintaining the vital integrity of the bet cell process. Like chaos construction, but without regions, just the lines. Yeah. I kind of want Christoph to make a Superfuzzy Arrows 3 where it's also a chaos construction, but again, that might also go back with the why my colleagues call me an anarchist business. Let's see. Okay, so this has to be an 8 because there needs to be an 8 in the box somewhere, and it's not going anywhere else. So I'll put an 8 in the corner just to impossibly lose track of what's going on. Let's see. Okay, so yeah, we've had like people turn in just a blank normal Sudoku grid, but maybe we should have someone submit to Simon a blank grid with no regions either. So it's a chaos construction where all the rules are over in the thing. Please don't suggest I do this puzzle, by the way. This is only something I want to see Simon do. Let's see. Row the 3 in box 1. 3 looks at box 1. This 3 looks at box. I got it. Okay. So that's a 3. Okay, so now I need a 3 over here somewhere. I never did quite figure out why this had to be a 6. I believed the claim, but I did not yet spot why row 8. Oh, it's row 8, column 5 that has to be the 6. Because there needs to be an 8 in this box. Got it. It's a locked candidate. The 8 in this box is definitely in this row, so this is a 6. So that's an 8. So bet cell is an 8. Did we have any winners, Directionary? This is a 4 or 5 to finish the column. This is not a 6. Logan won! Congratulations, Logan! Let's see. We'll see what your prize can be. This is not a 6. Because of the column. Wow, but back when puzzles had numbers, you were bucking the trend. That's pretty cool. 2, 3, 4, 5, 6, 7, 8, 9. I don't understand how people set puzzles with numbers because I don't know how they decide where to put them. It really is sort of a mystery to me how people do that. Uh, let's see. Okay, so this box is missing a 4, 5, 6, 7. Let's see. This box is missing 3, 4, 5, 6, 7, 8, 9. Okay, this is not a 6 or a 7. It's a 3 or a 5. Let's see. Row 3, column 1 is a 4. In order to make this a 9, do I know that this is a 9? Oh, yes, because it's not a 10. Got it. Okay. Wow, that was I was very slow on that one. This digit's definitely a 4. Thank you, Donovan. Welcome, by the way, Donovan. I think I've seen you once before, but welcome. I'm glad to see a lot of new faces today. Yes, if this were a 5, this cell would need to be a 10, and there's already a 1 in the row. So that's a 4, and that's a 9. That's not a 9. So this 4 sees down here that that's not a 4. This 4 looks over here and sees that that's not a 4. So now the 4 in the box goes there. So that's not a 4. It's a 5, which makes that an 8, which makes that a 7, makes that a 6, makes that not a 6. 5, 7 pair in the row makes that a 6. Makes these not 6s, which they already weren't, but we'll go with it. Let's see. Did I remove the wrong digit in row 9, column 1? Uh-oh. I probably did. Yes. Okay. Sorry. This cell was marked as 4, 5, or 9, and it's not 9 or 4, which I did by the wrong way. We'll just say the wrong way. I did it bad, but I did it gooder this time. So this is the circle on this arrow. This is now an 8. This cell's a 7 or an 8, but it's not a 7, so it's an 8. That's a 7, that's an 8. Let's see. 1, 2, 3, 4, 5, 6. That's a 7. Oh, we've got a 1, 2, 3, 4, 5, 6, 7, 8. Okay, so Barbie is claiming that this is going to end up being a 6. Let's convince ourselves of that. Okay, well, it's not a 5 because it would put a 5 over here. So that's not going to work. And it's not an 8 because this cell just can't be an 8 by itself. So this is a double 6. Now, the only problem with this puzzle is I don't know which of these is the circle. And so I think this puzzle has 2 solutions. I'm going to put the circle here. Actually, see, this is the problem. I've got to decide aesthetically which looks better, circle here or circle here. Oops. I didn't want to put a circle there. People can vote in chat. Which circle looks better? Number 1 or number 2? Cast your votes now. This is a 4. That's a 7 in order to finish off the row. That's a 5. That's a 3. These are not 3 or 5. I'm sorry to be teasing you about it now that this puzzle is I forget your exact term, but old. This 8 looks up and sees that that's a 5 and that's an 8. If the puzzle's older, maybe people weren't used to marking these kinds of things in the grid, and so there was less concern about uniqueness of things that weren't numbers. Because it wasn't even that long ago that people used to not even bother filling in like the ominoes in chaos constructions and whatnot. But now that seems to be the thing that people want to do. That's a 7. Let's see. These 2 digits have values. Those values are a 4 and a 9. That's a 4. That's a 9. Okay, there's a vote for box 1. There's 2 votes for box 1. 3 votes. 4 votes. Okay, so democracy has ruled that this will be the circle. Should we make it purple just to highlight that democracy has put the circle here? Let's see. Okay, so let's fill in the rest of this box. could probably do that. 3, 4, 5, 6, 7. These are not 3 or something. These are not 5 or 7. Okay, so that's 6. That's 3. That 6 looks over and says that's a 7, so that's a 5. So that's a 7. That's a 6. That's a 5. That's a 7. That's a 5. I did get all my 2s, right? I'm going to feel really embarrassed if I finish the puzzle without getting all the 2s. Yeah, it looks like we did. Nice puzzle, though. I really enjoyed the thing. Yeah, I can see if the people are less Sudoku-y, they might not complain about the uniqueness thing. It's actually a little weird to me how focused the puzzle community is on uniqueness overall. Like if you look at something like The Witness, tons of puzzles in The Witness don't have unique solutions, and people don't seem horribly offended by that. Or like Baba Is You, or lots of other sorts of puzzle genres. And of course, there's puzzle genres where there's a score. Row 9, column 1 is green. Oh, yes. Minus point to me for failing to do that. This one also should be green because it's not on an arrow after chat voted. So yeah, we missed a couple of them. Yeah, that's a really cool idea. I bet this would be a very popular idea to sort of play around with a bunch of variations on. Like this is definitely something where there's just a lot of neat possibilities with the arrow, but you don't know where the circle is. I have seen a number of puzzles where there's lines that are like fake arrows, where it's something like you put these numbers on a line, and all the line means is that one of the digits is the sum of the others. Which is kind of like this, but this one having the arrow in the middle so that you don't know where the sum split is really interesting. Row 9, column 7 is green. Well, it was green because the ones had a green flash, even though it's sort of weird that the ones and twos inherited a green flash. There's a lot of mechanics called double arrows. I'm guessing you don't mean my double arrows. But let's see. All right. I'm going to take a real quick break to refill my drink, and then I'll be back with another puzzle. Alrighty, welcome back. So as your reward for guessing the the bet cell correctly, and not at all because I had planned to do this puzzle next anyway. Logan's puzzle is next. So Logan has a quadruple puzzle that we're going to do, and so the way quadruple puzzles work is that these circles indicate the digits that are contained around them. So, for example, these digits are 3, 4, 5, and 7. These digits are 6, 7, 8, and 9. These are the powers of 2. These are 1, 2, 3, 9. 1, 2, 3, 4. 6, 7, 8, 9. 1, 2, 3, 4. 6, 7, 8, 9. Okay. And so with those pencil marks, we've almost but not quite removed the need to even have the rules for the puzzle, because we do need to make sure we actually put all of 1, 2, 3, 4 around here. Okay. Now, we have another rule, which I will actually read this time, which is that all x's and v's are given, meaning that no pair of cells sum to 7. Sorry, 7? Where did that come from? No pair of cells sum to 10. Pair of adjacent cells, I should probably say. No pair of adjacent cells sum to 10 or to 5. Okay, so that is the rules here. We don't care about 15. No, we do not care about 15. All right, so one thing that you often see in quadruples that may or may not be useful is that you look for digits that are in common between two sets that are in the same rows. So, for example, these two have in common a 7, so I know for sure that one of these two cells is a 7. Okay. Subconscious desire for people to create a puzzle where no pair of cells sums to 7. Interesting. Okay, so now, interestingly, because this can't be a 2, this cell can't be a 3, because if this were a 3, it would now be next to the 2, and I can't put a 3 next to a 2. So the 2 going in one of these 3 places means that's never a 2. Sorry, it means this is never a 3. So now the 3 going in one of these places means that's not a 2, except we already did that one. Let's see. Are there any obvious gimme things? Okay, there is an 8 on this quadruple, so that can't have an 8 in it. 1, 2, and 3 on this quadruple actually makes that a 4. So my deduction is going to have been proved worthless. But anyway, I don't know that we get to dance for this digit, but this digit's a 4. That's a 1. So that's a 3 and that's a 2, just to make the negative constraint work out. So I guess we got to use the logic a little bit there to actually fill in the rest of this. So I think 4 digits. We'll dance for 4 digits. If there's something where it's like there's no logic at all, you just sort of read the rules and fill it in. I don't usually do the dance until later, but we'll call that good enough. We'll set the bar low today, and then we'll try and raise it as the stream goes on or something. Let's see. Columns 1 and 2 have 1 and 2 in common. So I need 1 and 2 here, because basically the question Alvaro is asking is, where does 1 go in column 3? Not there, not there. So it only goes there. So that's a 1. Russ has the same point. So that's not a 1. Okay, and so now let's do the same thing. That's not a 1. So one of these is 1. So this can't be a 4 for that reason. So yes, we will try and limbo under the bar. That's what you're supposed to do with the bar, right? When you raise the bar, you're trying to limbo under it. Is that the way the expression works? I think so. Fairly confident. Let's see. So So I know the 2 and 3 here go... Oh, okay, so I can do the same thing. Okay, so the 2 is in one of these two cells, and because the 2 is in one of these two cells, the 3 can't be in one of those two cells. So the 3 is definitely in one of these two cells, which then removes the 3 from over here, means the 3 is in one of these two cells. Once the 3 is in one of these two cells, the 7 can't be, because if the 7 joined those, then that would wreak havoc on digits summing to 10. So one of these is a 7. Let's see. Nicholas says 8 in box 8. That sounds like a good thing to look at. So there are aligning 8s here. So the 8 in box 8 is always in one of these two cells. I don't think I can do better, but it's in one of those two cells for sure. Let's see. I was trying to see if I could do something with the 7. Let's see. 7 in box 6. Is in one of those two places. I've completely forgotten that we had it pencil marked, so it was a complete surprise to me. When Barbie said it, I thought it was a great idea, but then it turned out that we'd already pencil marked the 7 in box 6, and then I had forgotten completely about it, which sounds like me. The 6 in box 1 can't go next to the 4, so the 6 has to go in one of these two places, for whatever that's worth. The 8 in this box has to go in one of the corners. Trying to figure out one of these tuples is going to have a really nice negative constraint trick. I mean, there's already been a lot of neat negative constraint tricks, but I'm thinking there's something I'm missing involving like the 1 and the 9 or something. Let's see, where is 3 in column 5, asks Jay. Let's see. Well, it's not there. So... let's see, is there a reason this has to be a 3 or can't be a 3 or something? I know the opposite sides here add to 5. That's how this is going to work. Oh, not next to the 7. Oh, wow. Yeah, great. Yes, I'll be done before 9 p.m. my time, Ranks. So the point is, and this is a beautiful point, I need to put a 3 in this column somewhere. It's not up here. This is Jay's point. I can't put it next to the 3. So there's a 3 in one of these cells, which means in particular this cell's not a 3, which means one of these is a 3, which means this cell's not a 2, because 3 and 2 can't go next to each other. Yeah, so one of these is a 2, but that's not exciting. Let's see. So the 3 and 7 are kitty corner to each other here. It's either 3 and 7 or 3 and 7. I don't know that immediately helps me. 3 in column 3, says Ambrose. Ah, yeah, good point. 3's not up here because there's a 3 on the quadruple, and so it goes all the way down here. Let's see. Two in box 7. see. If I put a 2 here, I'd have to put an 8 there. That seems fine. Let's see. Nicholas, where can the 2 go in box 5, 6, 8, 9? It cannot be adjoining a 3. Well, I mean, the 2's on the quadruple. I know 2's not next to 3, but I don't know which of these is a 3 yet. I know one of these 3 is a 3 in this box. Let's see. Yeah, so yeah, the 1 and the 4 in this box, the 1 and the 4 are kitty corner, and the 2 and the 8 are kitty corner because we have to avoid those pairings. But there aren't any surprise pairings. Where's 2 in row 3? Asks Barbie. So the 2 in row 3 has to be in one of these 2 cells. I don't think by any particularly special considerations. Okay, so now where is the 8? I guess the 8 in this box is now in one of these cells. Okay, so this is actually interesting. And Barbie has this follow-up. I can no longer put the 8 in one of these cells. So now the 8 goes vertically. So now this isn't an 8. Oops, sorry, is not an 8. Let's see. Oh, maybe I should actually rate out. What are these? Because when I take out 6, 7, 8, and 9, that leaves me with the awful problem that I now have to put 1, 2, 3, 4, 5 in here. But that's going to be quite difficult to do without accidentally creating a 5, isn't it? Maybe not. Maybe it's okay. I was hoping that it would do something, but I don't know. Yeah, I guess I can't quite do anything profound with that. I know this cell isn't a 2. I know that cell's not a 2. I know that cell's not a 2, and that cell's not a 2. Something fancy coming up. Oh, no. Well, hopefully chat can find the something fancy. Can 2 go in row 6, column 6? If this is a 2, then that's a 3. Is there something wrong with this being a 3 that Nicholas sees? Since row 7, column 7 is limited to 1, 3, 2 can be placed in the quad. Okay, so Russ sees the same thing that Nicholas sees. I don't see why this can't go 2, 3, or 4, 1, with the other one going this way. Try placing 2 elsewhere. So if this were a 2, that would be a 3. And then this would be a 4, and that would be a 1. Okay, 2, 3, 4, 1. What am I missing? No, there's no consecutive constraint. The only constraint is that it's anti-XV. Let's see. Barbie says row 6, column 3 can't be a 9. All right, good point. Okay, that would make 10 with the thing next to it. Good. Let's see. Seven in this box is definitely in row 1. The 7 has to be up here. Because if the 7 was... Well, the 7 can't be there, and if the 7 was here, it would go with a 3. So the 7's up there, which is, I guess, just another way of saying the 7's down here, which I already have kind of pencil marked. Let's see. Nicholas says, so you can eliminate 2 from row 6, column 8, and row 8, column 6. So yeah, so either this is 2 with a 3 there, in which case, of course, neither of these is a 2, or this is a 4 with a 1 there, in which case this is a 2-3 pair. I agree these cells are not 2. Oh, is this a Fistomathel thing? This does suddenly, now that people are talking about set, it does sort of seem like maybe this is a Fistomathel's theorem problem. So if you've not seen this before, I'm going to guess this is what I'm supposed to do. It is the theorem that in any Sudoku grid, the yellow ring here always contains exactly the same digits that are in the purple cells. And that's not so hard to prove, but I'm not going to prove it right now. But you can look at Cracking the Cryptic has 80,000 videos where they prove it. And Rank School, I'm sure, Ranks has proven it many, many times. But I think Ranks has a go-to video for proving this, right? But the point of that is I know exactly what digits have to go in the Fistomathel ring, as it is known. Namely, I need 2 1s. I've got the 2 1s. I need 2 2s. I've got 1 2 here, and then I need another 2. And the 2 can only go in one of these places or that cell. Let's see. Looks like 2 3s. We've got our 2 3s for sure, because one of these has to be a 3. We need 2 4s. One of these is a 4. Maybe one of these is a 4. 1 5. Okay, so the 1 5 has to go in one of these places. I don't know which one, but I don't have any 5s marked as of yet. 1 6. So the fact that I only get 1 6 tells me that it's not the case that both of these 6s are on the Fistomathel ring. So one of these 2 cells is a 6. So just to explain that again, because that's a little weird, I can count the purple cells, and I know the purple cells contain exactly 1 6. And so the yellow cells, if you believe me, I'm a mathematician, you can trust me, contain exactly 1 6. And so if I look at these quads, it can't be the case that I put a 6 in both of these, because that would be, you guessed it, 2 6s. So one of these 2 cells is a 6. Let's see, 7s. we have 2 sevens to appear on the Fist-O-Mafel ring. None of them are there. We might have one of them there. We definitely have one of them here. And we might have one of them there. That's not so exciting. Let's see. We need 2 8s. And then we need 2 9s. Okay, I don't think that got me very much. Let's see. I hear there's a 1-2 pair in box 3. Do I know? I can do 1s in row 3. So why is this not a 1? Or is this a 1? 1, 3 in row 7, column 7. Also excluded some options from row 6 and row 7. Oh, I have... okay, right. This, okay, got it, okay. I already have 2 1s, right. There are only 2 1s in this whole, whatever you want to call it. And so because one of these is definitely a 1. I don't know which one, but because that can't be a 1, one of these is a 1. So this can't be a 1. Which means, and this is gorgeous, the other 1 in row 3 joins its friend the 2 over here. So this is a 1-2 pair. And so that makes this a 6, 8, 9 triple in order to finish the box, which makes this a 7 just for freebie, right? People agree with this. This is a 1-2, so this is a 6, 8, 9, so that's a 7. So these aren't 7. And so now that 7 comes down here. So this is 6, 7, 8, 9. So this is a 1, 2, 3, or 4, or 5 for sure. It's not a 1. So this is 2, 3, 4, 5, but it's not a 3 either because of the negative constraint. Let's see. Okay, so this is a 2, 4, or 5. Interesting. Okay, so now the complete lack of tension on the 6, 7, 8, 9s is very concerning in this puzzle. Let's see. I do know that there's a 7 in one of these 3 cells. Now, okay, so now we know we need 2 7s to show up on the Fist-O-Mafel ring. And once this stopped being able to be 7, we now actually have a given 7 to chase the 7 out of everywhere else. So the second 7 needs to go, needs to eat away from, or needs to be in one of these 3 cells. So therefore that is not a 7. Okay, so these are a 6, 8, 9 almost triple. So that means there's a 7 in this row, just in box 5. These are the only 2 places for there to be a 7, which means that's not a 3 anymore because it would be sandwiched between 2 7s. So one of these 2 is a 3. That's interesting. One of these is a 7. Yeah, one of these is a 3. Yeah, and that's a good point. 7 in row 3 now has to go over here. Probably has for a while, but certainly now 7 has to go over here somewhere. Good catch, Ambrose. Oh, yeah, and there's definitely a 7 over here. It's a different way to... but I think that's okay. Let's see. Should I pencil mark what these cells can be? I probably am supposed to pencil mark what these cells can be. 2, 3, 4. Oops. Not like that. Sorry. Let's center mark what these could be, because probably I'm supposed to just exhaust and know what these are. So they're not 2. They could be 3, 4, 5, 6, not 7. They could be 8 or 9. Okay, but this one is not 3 or 4. For sure. This one is not 3. Is that really it? I was hoping that it would be more dramatic than that. This one's not 8 either, actually. So this is only 1, 5, 6, or 9. This is only 2, 4, or 5. This one's a gigantic pain because it's got just options out the wazoo. The row 3 one is not a 1. Right, because there's a 1, 2 pair over here. Why do I have a 1 pencil marked here? Oh, I shouldn't have a 1 pencil marked there. That was just me mispencil marking stuff. There's a 1, 2 pair over here, so this is not a 1 either. So this is only 5, 6, or 9. Let's see. Sam contends neither of them is a 1 because I already have my allotment of 1s for the Fistamafel ring. Good point. Okay, so now I think we should think digit through digit of the Fistamafel ring and see if we can knock any of these out. Okay, so I know there's only 1 5 in the Fistamafel ring. So one of these 3 is a 5 for sure. So, I mean, I guess I can state the obvious. This cell's not a 5. Let's see. 6s. There's only 1 6 on the Fistamafel ring, and that's already there. So this and this are not 6. Because we already have our 6 on the Fistamafel ring. It goes there or there because I can only put 1 6 in the box. So neither of these is 6. Let's see. 9s. Do I know anything about 9s? There are 2 9s on the Fistamafel ring. Don't immediately see why this being 9 is a problem. What about 4s? There are 2 4s on the Fistamafel ring. That's one of them. So if this was a 4, that would be a 4. What happens if this is a 4? If this is a 4, then this can be neither a 4 nor a 1. So this becomes a 2. Then these two are a 2, 3 pair. So as soon as this is a 4, that's a 4, and that's a 1. I don't know if that really does anything humongous. Wow. Okay, so now Logan asks where 1 and 6 go in column 5. That's a hard spot. Because 1 and 6 now, remember, are locked into these places in box 5. So in column 5, 1 and 6 actually only can live in these places. So that's a 1, 6 pair. Okay, so now we need to ask what these cells are. So we've got rid of 1, 2. We need a 3. It's not there. We need a 4, 5, 6. We've got a 7. And we need an 8 and a 9. This cell's not a 9 for sure. It's not a 4, just both because of the negative constraint on that side. it's not none of these are 6. I don't know why I wrote 6. I should not have written 6. That was the whole point of all of this. I don't think I can say for sure about that one. Okay, can I rule out this from being a 3? If this is a 3, that's a 4, that's a 1. And that would be a 2, and that would be a 3. No, I think that's okay. 4 in box 2 can't be with a 1 or a 6. That is a good point. Okay, so that is beautiful. Okay, so that is a great spot, Barbie. So now where am I putting 4 in this box? And the answer is I'm not putting it in this row because I'd be putting it next to a 1 or a 6, both of which would make 5 or 10. So the 4 actually just goes in these two cells, which chases the 4 out of these cells, makes that a 5-7 pair, makes this a 3-4 pair. Now, because of this being a 3-4 pair, maybe that doesn't do anything immediately. I was maybe off to, okay, the 7 now, I guess I can say the 7 in this box now has to go in one of these cells. Let's see. Row 2, column 3 is a naked single. Let's see. Can't be 1 because of the negative constraint. Can't be 2 because of the row. Couldn't be 1 because of the row either. It's not 3 or 4. Could be 5. Can't be 6 because of the negative constraint. Could be 7. Looks to me like it could be 8, but can't be 9. Oh, I'm in the wrong place. Row 2, column 3. Sorry. Take 2 on this. Let's see. It's not 1 or 2. It's not 3 because of the quad. It's not 4 because it's sitting next to a 4. It's not 5 because of this. It's not 6 because of this. It's not 7 because of this. It could be 8 and it's not 9. So it is an 8. Excellent. Naked single. Yes, this is the only place an 8 can possibly go in this one. You're right. It's always the second row 2, column 3. That's one of the tricks of Sudoku. Okay, so this is an 8. So this is not an 8 for what it's worth. That's not an 8 actually. That might be worth more. These two cells are a 5, 6, 7. They are a 5, 6, 7. Oops, wrong marks. These cells are a 5, 6, 7. Let's see, we do need 2 8s on the ring. So one of them is coming from here, and one of them is coming from here. Right. And the one of them that's coming from here knocks an 8 out of this. Right. Because I need 2 8s on the Fistamafel ring, and I can just count. One of them's got to come from these two cells. And then one of them now has to come from these two cells, so this can't be an 8. That is a good spot. So this is now a 6 or a 9. The top one is not 7. The top one is not 7 11 tools. 8 in row 3 is on the ring. Yep. there's the 3, 4, 5 could be anywhere at once. Row 1, column 3 is not a 7. Ah, right, because the 7's up there. Okay, got it. Yep. We have pencil marked 7s up here. Aren't we in a set that's using all the quad cells? One of these two has to be... Yeah, one of these two is definitely a 7, so that uses all of our 7s, but that's not super helpful. 9s? Yeah, there's 2 9s there's supposed to be. Ah, okay, so there's a... Yeah, so... So people are proposing to modify the set by adding this to both, and then taking row 4 and 5 out of purple or something. I'm not quite sure I understand exactly what people are proposing to do with the set. Let's see, there's a quintuple in column 7. That sounds good. That's not column 7. Yeah, I think this is a quintuple. All right, this can't be a 5. We've already argued that because all the 5s on the ring see it. Got it, yep. We said that before and then didn't pencil mark it. But then it won't be balanced, right, Ambrose? Or am I just giving up on making it balanced? So I mean, I can certainly do that. I can make this yellow, and then add these two to purple. And now purple is no longer equal to yellow, but now purple is one more set of the digits 1 through 9 than yellow. Let's see. Okay, so Derek wants to color. Let's try what Derek wants. Row 1, 2, 8, and 9, column 1, 2, 8, and 9. Okay, so these are blue. These are blue. And these are double blue, if I understand what Derek is suggesting. What's the other set? Or did you actually want me to do row 1, 2, or did you want me to do this as two separate sets? Maybe you wanted me to do this as two separate sets. So that's the blue set. That's the yellow set. The problem is this seems to cancel everything I want, doesn't it, Derek? So I read row 1, 2, 8, and 9, column 1, 2, 8, and 9. Is that not what I'm doing? Yeah, that unfortunately cancels. Yeah, that seems to cancel the relevant cells. No problem. I often end up canceling the things that I want to. Let's see. Logan is suggesting row 3, 4, 6, and 7. Versus row 1, 2, or sorry, versus column 1, 2, 8, and 9. So I think this is going to get us where we were previously. Well, don't feel too bad. Logan made the puzzle, so Logan guessing the correct set quicker than you is not necessarily an indictment of your set ability. So this is the desired set. Yeah, this is exactly what Ambrose suggested, basically. With maybe with stripping out column 5. Okay. So now we can cancel quads. Okay, so we've got 1, 2, 3, 4, 1, 2, 3, 4. Oh, we don't have any of those, but I can cancel a 6, 7, 8, 9 with a 6, 7, 8, 9. That I can do. And no. I haven't, Aaron. Totally Normal Cat usually tells me which of their puzzles I will love, and then I do those. That's usually my my thing, and I generally trust them because they have so far steered me towards exactly the Totally Normal Cat puzzles that I want to do. Row 4, column 6. Am I missing something about canceling the quads, Derek? It seems like this is designed so that I can do more cancellation, but I don't actually see more cancellation. Where do 2, 5, and 7 go in row 5? And can they go in purple again? So purple already has 2 7s. Yellow has 2 7s. Wait, what am I even talking about? Oh, yeah, you can keep canceling digits. Okay, so let's try and cancel digits. So let's try and keep a count here. And I am just going to let's see. Okay, so let's just go a digit at a time. Ones. How many ones are there in yellow? Well, there are 2 ones in yellow. And I'm sure there are not any more. There are 2 ones in purple, and I'm sure there aren't any more. So these digits are not 1. 2. There are 2 2s in yellow. I'm sure there aren't any more. There are 2 2s in purple, so I'm sure there's not any more. So the 2 is not in these purple cells. So these are not 1, they're not 2. Okay, what about 3? Could these cells be 3? Oops, sorry. I'm just going to do this one digit at a time because I don't want to pull out a sheet of paper. So could these be 3? Well, there are 2. Sorry, there are 3 3s. Okay, so this is the point, I think. There are 3 3s in yellow. So there's definitely 3 3s in purple. So one of these is a 3. Good. Okay, 4s. There are either 2 or 3 4s in yellow. I'm not sure. So there are either 2 or 3 4s in purple. So there could be a 4 here. Okay, 5s. So there is a 5 in purple. So there has to be a 5 in yellow. Uh, and it's going to be one of these cells, but we already knew one of those cells is going to be a 5 for the column. But I could never have, this is the point, I could never have a second 5 in purple, because if I had a second 5 in purple, the only place I could put it in yellow would be in the same spot. So none of these, so we have our first deduction, none of these are 5. Okay, 6s. There are... Yeah, there's 1 6. Precisely. There's precisely 1 6 in yellow. So there's going to be 1 6 in purple, and it's going to be over here, but that we just knew by Sudoku. 7s. There is 1 7 in yellow, so there needs to be 1 7 in purple. It's up there. So I can't have another 7 in purple. There's no place for me to put it thanks to this given. So these are not 7. Oh, I guess that's just repeating the given 7. 8. I'm afraid at the end of this, I'm just going to have recovered my pencil marks and nothing else. But let's see. Okay, so 8s. Yeah, there's 1 or 2 8s, so there could be an 8 over here. We don't know. And 9s. Yeah, and I don't know anything about 9s. Okay, so now, where do 2, 5, and 7 go in row 5? They have to go, I'm presuming, in these 3 cells. These are the only 3 cells in the row that can be 2, 5, and 7. Okay. So that's not a 4 anymore. So this is a 2, 5, 7 triple. Okay. One of those is a 7. Okay. So what does that do? Knowing that there's a 2, 5, 7 triple in these cells. Let's see, row 4, column 6 is a 6 via 9s on the Fistomaphel ring. Okay, so we have to go back to our other coloring now. Have we gotten everything we're supposed to out of this coloring? Let's see, so 9s. So yeah, there's... The annoying thing is this cell can be a 9. Why can't row 7, column 5 be a 9 instead? Oh, I think this can... As far as I'm aware, Dictionary, this can definitely be a 9. There are 2 9s on the ring. Row 7 must be one of the 9s. Okay, so let's go back to the other coloring, because I don't think we can do this without the other coloring, without losing anyone who's not done a lot of set puzzles. So remember that that these are equivalent sets. And so The point that Chad is now making is that I know there's 2 9s in purple just by counting. So there have to be 2 9s in yellow. But I'm going to highlight every single cell that could be a 9 in yellow. And it's those cells that could be 9s in yellow. So one of these definitely is a 9. And one of these definitely is a 9. Now, does that get me anything? I think I've now explained what I understand about what Chad has told me about 9s. So row 3, column 5 is forced to be a 5. I definitely don't understand why that would be the case. And one of these is a 9, but these are not in danger of accidentally... okay, so we had a problem because of this cell. Okay. Let's see. Logan says if row 5, column 5 is a 4, then 2 is placed in box 5, not in row 5. So if this is a 4, that's a 2, just because, well, sudoku. And so if this is a 4, that's a 2, which means that's a 2, because we have a 2, 5, 7 triple. But that's not, I mean, they just put the 2 here. Like there's nothing, it's not illegal to put a 2 here. Yeah, we do have to think about the 5 and 10 constraint. I'm sure that's essential to what's going on. Not that I have any idea how, but I'm sure it's important. Let's see. Yeah, so okay, so maybe the point is the point this is always a 2? So if this is a 4, we've said that's a 2. If this is an 8, then it knocks those 2 out. That still has to be a 2. If this is a 9, then I don't see what happens. If this is a 9, that's a 6. That's an 8. Okay, so here's a thing. This cell's never a 2. Because we've said if this is a 4 or an 8, that's a 2. If this is a 9, that's a 6, so that's an 8, and this is not a 2. So I can at least remove 2 from this cell. So that's a step. So we've removed a digit. Ranks notes that, the 4 in this box has to be in one of 3 places. It has to be in one of these 3 places. So, okay, so Sam is getting it. Okay, so if it's a 9, it forces a 5 in row 3, column 5. Ah, yes. Okay, beautiful. Oh, God. Okay, great. So if this is a 9, then this becomes a 5, but we only get 1 5 in the entire Fistamafel ring, and so then that's a 2. So the punchline of this, at the end of the day, is that this is always a 2. In a very weird way that's a little hard to see, but this is always a 2. So that's not a 2. So this is not a 2 or a 3. It's a 1 or a 4. So this is the 1 or the 4. So that's a 3. That's a 2. Let's see. Okay, so these aren't 3 or these aren't 3. These aren't 2. Good night, Nicholas. Thanks for coming and participating as always. Always glad to have your help. Okay, so now Yeah, we've got that. Okay, we know. Okay, this can't ever be a 4 anymore. That's one thing that's useful, because if this were a 4, it would be next to a 1, 4, so that's not going to work. 2 in box 9. Can't the 2 in box 9 go in either of these places? Fives can come out of column 5 in box 5. Yes. Yes, thank you. So one of these is definitely a 5. Three in column 9 and box 8. Yeah, the 3 is over here. This 3 could never be here. This 3 is not here. I think we accidentally placed a 3. Because I think now 3 in this box can only go here. Yeah, we accidentally placed a 3. I don't know how, but we did. That's a 3, which means this isn't a 2 anymore. Which now, as chat has been noting for a while, says that's a 2, that's a 1, that's a 2. Just immediately. This can't possibly be a 5, because if this is a 5, it would put 1 and 4 next to each other. So that's not a 5. So that's a 1, 4 pair in the row. Let's see. So got 1, 2, 3, 4. So these are from 5, 6, 7, 9. Not 8. Because there's an 8 over here. This is not a 3 because it's next to a 2 now. Let's see. This being a 1 or 4 means this isn't a 6. Because 1 and 4 can't go next to 6, as previously noted. So this is an 8 or a 9. Row 3, column 6 says Sam is an 8 because of XV stuff. This can't be 8 because it's next to a 2. That's the point. Okay, so that's not an 8. So that is an 8. So that's an 8 in order to finish the quad. Why can't 1 go next to 6? Never mind my claim that 1 can't go next to 6. It's 4 can't go next to 1 or 6. Sorry. This could be a 6. I don't think I broke it, though. I think I can just put the pencil mark back and it'll be fine. Let's see. Negative constraints in row 3, column 7. I don't see any negative constraints here. Row 5, column 3. Sorry, row 5, column 3. Yes, so this is not a 9. Row 4, column 8. I don't even have this pencil marked. Should I pencil mark this? Is that what's being suggested? Row 8, column 9. Yeah, this is not an 8. Okay, 3 and 7 in column 3 are placed. This is not a 3, so that's a 3 because of this 3, which then dislodges the 7. Oops. Dislodges the 7 from that set, which now places the 7 in the column here. This is Barbie's point. So that's now a 7. Oh yeah, typing on a keyboard is on a mobile keyboard is very difficult. I appreciate those of you who go through the effort to help me on, even if you're on a keyboard. This can't be an 8 because it's next to a 2. Uh, this is a 5, 6, or 9 just to finish the column. 3 is placed in box 5. That box. Ah, yes, because it's not next to a 2. Gotcha. Haha. There you are. Okay, so that's a 3. This is not an 8, I'm noticing, because it's next to a 2. I was just trying to see if there was maybe some negative constraint nonsense here, but I do not see it. If there is. Let's see. 3 is placed in box 5. Okay. What else do we have to bring us joy in this life? Yeah, 1, 6 can't go next to 4. Maybe I should pencil mark this cell. It's really unappealing to pencil mark that cell. Let's see. Hey, Panthera, how are you? As so often happens, you have come nearly at the end of the puzzle, or nearly at the end of the stream, I am sorry to say. Row 5, column 2 can't be a 4, right? Got it, thank you. Hidden single 2 in row 8. Because this can't be a 2 anymore. That's not a 2. Wow. Okay, yeah. So 2 in row 8, actually. It can't go next to this 3. It can't go next to that 3 either. And we've already got one in this box. Can't put it on top of the given 7. It's not this 3. So in fact, that's a 2. So that's an 8 immediately. So those are not 8. That's not 2. That's a 1, 4 pair. This 8 comes over here. Says that's not an 8. These aren't 8 anymore. So there's an 8 up here. So that's the 8. Let's see. I got that one. 7 is not 2. Yes. Take notes. These notes will help you in your future solvings. Let's see. 2 in box 8. Yes, I do have to put a 2 in box 8. Thank you, Josh. So that's a 2. Now we have to put a 2 in box 1 somewhere, I am told. And it's not there. And it's not anywhere other than here. So that's a 2. That's the 3, because the 3 has to live opposite the 2. Otherwise, it will live an unhappy life. The 3 means this isn't a 7 anymore. So that's a 5, 6 pair, which means that is a 7. That means this isn't a 7. So that is a 7 by pencil marks, which we shall not question. Yeah, I feel like set makes for beautiful puzzles that I don't like to solve as a general rule. Although I will say almost every set puzzle that I've ended up solving on stream, because I basically only solve set puzzles on stream by accident, has ended up being really nice in its own way. This is a really intricate and interesting combination. Like I feel like almost Ranks does these videos where he just has the solve path in front of him and goes over it for a grid. I feel like this would make a very beautiful like puzzle for someone to write a solve path for and go over it. Just because so many of the deductions are so surprising. Yeah, I'm terrible at identifying that the word set is present in a title. That is one of my weaknesses as a person. Uh, but yeah, certainly set it has its fans amongst amongst the community. Uh, let's see, 9 in column 3 is limited to box 7. Ah, yes, okay, I agree. 9 is in one of these two cells, because I have to put a 9 in this box, or sorry, in that column, so this can't be a 9. I'm pretty sure I can't put a 6 next to a 1 or a 4, right? Is that how that works? Let's see. You didn't let me get away with it last time, but maybe this time you'll let me get away with it. 3 in box 4 is placed. Because it can't go next to the 7. Got it. Beautiful, beautiful Yab. 3 knocks those out of the way. I mean, the nice thing about doing puzzles is even your so it's always fun, no matter what sort of puzzle you're doing, in some way or another. Let's see, row 6, column 7. Let's see. Yeah, Ambrose, before I accidentally said, oh, this is next to a 1 or a 4, so it can't be a 6, and then chat pointed out that no, that's not how it works. That it is not a thing. Okay, so if row 6, column 7 is a 4, what happens to 1 in box 6? Okay, so if this is a 4, I'm now forced to put a 1 nowhere. Interesting. Okay, so I'm trying to figure out what really happens. What's really happening? The 1 is in one of these two cells. Okay, that's the point. I can pencil mark 1 is in one of these two cells, and as soon as 1 is in one of these two cells, that has to be a 4. Nice spot. Yeah, that is a very nice spot. I was just trying to figure out how to articulate it to myself. So sorry. Can't be a 4. I did it backwards. I did it backwards again. Can't be a 4. So that's a 1. Thank you. Thank you. I caught it that time somehow. So these aren't 1. Aren't 1. So this now is a 1. Let's see. So that's a 4. Okay. 3 in box 6. Not there. Can't 3 in box 6 go any of these places? Where am I missing something? It's not there either, because it's next to a 2. But can it go either of the... Oh, there's a 3 in that row somehow. While I wasn't looking, someone put a 3 there. Okay, so yes. So 3 in box 6 is without really any much thought there. Thank you. Good spot. Okay, the 6-9 pair in the ring eliminates 6 from row 7, column 4. Wait, isn't it the opposite? No, I do. No, I agree with that. There is only 1 6 in the ring. And so this is but it doesn't have to be a 6-9 pair. These could both be 9 because they're not, they could both be 9. That's the problem. Okay. 3-4 pair in box 3 is resolved. By that 3. Okay, so that's going to resolve all this stuff. So that's 4, that's 3, that's 5, that's 7. Let's see. Did that do any damage anywhere that I can take advantage of? It would seem the answer is no, sadly. This is not a 7. I can do that. So that's a 7. Okay, so I can place another digit. Let's see. One of these two is an 8. The 1 in this box is all... Oh, the 1 is placed in box 8. That's probably going to do it. Because 1 can't go here because it's next to a 4, and it can't go there because there's a 1 in the column. So the only place for a 1 in box 8 is there. And I think that might be the thing that we needed. Maybe. So that's a 5. That's a 6. Okay, that's not a 6. Maybe I was overly optimistic. Maybe we're not going to get that much out of it. It seemed like the sort of thing we would get a lot out of. To me, at least. Let's see. The 1 in this box is in one of these two cells. The 1 in this box is in one of these two cells, which means this can't be a 4, because if this was a 4, it would put a 1 there. So that's actually where the 4 goes in this box. I love the negative XV stuff. The negative XV stuff is just super fun for me for whatever reason. Let's see. Okay, so this row is missing 1. We've got a 2, 3, 4, 5, 6. We need a 7, 8, 9. Oh, it's not an 8. Oh, we have an 8. Never mind. 1, 7, 8, 9. By the way, hey, Jerian. I'm not sure I've seen you around before, but welcome. Glad to have you here. Let's see. This is a 1, not a... Okay, this is 1, 2, 3, 4, 5. No, not 5. In fact, actually, 5 is placed in this box. Let me do that. 5 is now only here. So that's not a 5. So this is 1, 7, or 9, but it's not a 7. So this is 1 or 9. So that 1, 9 pair puts a 6 there and a 9 there. Yes, please don't forget to like and subscribe. I greatly appreciate all of my subscribers. It is very helpful towards growing the stream and letting me do more fancy YouTube things. Let's see. Okay, so this digit should just be known. 2, 3, 4, 5. And then we've got 6, 7, 8, 9. Okay, yeah, so this is a 5. Yeah, the crazy fancy XV stuff that I do at some points. Okay. Can I use the super fancy XV stuff on the 9s in the same place? Yes, I can. There's no 9s here because there's a 1 in one of these cells. So that therefore is not a 9, it's a 1. Beautiful. And so that's the 9 and that's the 7. And this 1 means that's a 9 and that's a 1. Good spot, Jessica. That 1 places a 4 and a 1. That 4 places a 5 and a 4. That is not a 5 anymore. This is a 6-9 pair, so that's a 5. That's a 5. We'll successfully get CTC to enter it. 1, 2, 3, 4, 5, 6, 7, 8, 9. My most recent puzzle, Jessica, has the negative constraint, all hearts are given. I recommend that one. I didn't just want to put that line in a rule, but I did also kind of want to put those words in rules. Okay, what are these digits? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. Quad 6, 9 resolved in box 5. Ah, yes, got it. This quad needs to have a 6, so that's a 6. So that's a 4, that's a 6. That tells me that's not a 6. It is an 8 or a 9. Let's see. This is not a 5 anymore, so that's a 5. This is a 4, 8, or 9. And it's not an 8. This is a 4 or a 9. So now, because of the negative constraint, we now actually get this 8. Which gives us that 8. Okay, this is an 8 or a 9, and it's not a 9 because of the negative constraint. So that's an 8, and that's a 9, and that's an 8. So that's not an 8. 2, 3, 4, 5, 6, 7, 8, 9 for those cells. So yeah, these are 5, 6, 9. That one's not a 6 because of the 6 in the column. Somehow briefly I kept seeing 2 6s in the column, but I don't think there's actually 2 6s. But there is a 7 in the column, which gives me that that's a 5 and that's a 7 and that's a 9. And so that's a 6 and that's a 9. That's a 6. That's a 6 and that's a 9 and that's a 6. 6 and 9, so that's a 5. Let's see. Now, hopefully, we should be able to finish it from here. I'm moderately optimistic. This is not a 6. This can't be a 4 because of the 6. So that's a 9, that's a 4, that's a 9, and that's a 4. It's a really surprising puzzle. I really love the negative XV stuff that was used in a lot of neat ways. Like if there was a version of this puzzle without set, I would just absolutely adore it. But the setting here is really clever in so many ways. Like this must have taken forever to figure out how to put all of these pieces together. Like even just looking at the grid, like even before the grid is filled in, when you look at it, it's sort of startling that this could possibly have a unique solution. And then the way, like, it's really clear that, like, as you start to fill it in, that the Fistamafel ring should probably maybe be involved because you have quadruples literally in the corner. Like, even I was starting to suspect that. And yeah, the very end of the negative constraint, when it's like, oh no, where am I missing a negative constraint, can be a bit tricky. But I really like you've got to put all of these pieces together and sort of like play keep away with these pieces or whatever. I really enjoyed that. So yeah, that was a fun and interesting puzzle, and I'm very glad I had chat to help me through that one. Chat was very useful. Alrighty. That's going to do it for today's stream. Remember, on Wednesday, we have the 5-list stream, so we're going to be streaming 5-list puzzles probably all day long and probably into Saturday. So look forward to that. If you submitted a puzzle or look forward to it. It might not happen Wednesday. It might happen Saturday. Tristan is sort of organizing them by theme or whatever. If you have a puzzle that you intend to submit, but you haven't submitted it yet, please submit it by Wednesday in the thing. Yes, Ranksk is doing his daily Wordle-like stream today, which is why I did not do the Sudoku today. Otherwise, I might have. But I'm looking forward to seeing Ranksk do the Sudoku, and I will see you all on Wednesday. Again, please like the stream. Please consider subscribing if you haven't subscribed yet. Those of you who are patrons, we adore you. Thank you very, very much for your Patreon support. If you're interested in becoming a patron for as little as $1 a month, you can support the stream over on patreon.com/zetamath. Have a wonderful weekend, everyone. I look forward to seeing you all on Wednesday.